Astronomers have detected an alien signal coming from the closest star to our solar system.
They detected it in a very narrow band of frequencies, and that makes it, it cannot be through natural processes, a very narrow band.
This is a game changer because astronomers have hit the jackpot. This is their dream come true. A new chapter in astronomy has opened up.
After many years of dedicated research and construction, culminating in a Christmas Day launch, we are now receiving more full-color images from the James Webb Space Telescope.
We have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find because it's the nearest star to the Sun, and we are very excited about it.
Mark Eastman delves into the origins of the universe. Could this be the moment we've all been anticipating? The James Webb Telescope has just detected a mysterious signal from Proxima B. The closest exoplanet to Earth. Is this evidence of alien life? Stay with us as we explore this groundbreaking discovery that could transform everything we know about the universe.
But beyond that, even if there are things out there, there's no way we can see them because the light just could not have gotten to us by now.
In a revolutionary finding that has sent ripples through the scientific community, the James Webb Space Telescope, JWST, has reportedly picked up what seems to be the first ever alien signal from Proxima B, an exoplanet situated in the Alpha Centauri star system.
Discovered, orbiting around it. And the reason scientists are so excited is that this alien world is the closest there is outside our own solar system. It's being called Proxima B.
This event could signify a historic milestone in our quest for extraterrestrial life and poses profound questions about the existence of other civilizations in the cosmos.
Scientists looking for life on other planets like to talk about the Goldilocks zone, not too hot, not too cold, but just right. And now NASA's found a planet that's right in that zone. Degrees, and that's what makes scientists believe that the potential is there for life.
The potential is there, and it's very exciting because in the catalogs of planets that we now have, this is the first time we've had an Earth-like planet in the habitable zone of a Sun-like star.
Proxima B is among the most fascinating exoplanets ever found. Orbiting Proxima Centauri, the closest star to our Sun at just over 4.24 light-years away, this exoplanet was first discovered in 2016.
The discovery of another possible Earth-like planet that's grabbing worldwide attention today. It's true, scientists have previously said they believe there are other planets outside our solar system that resemble Earth in size and may have liquid water. But this latest finding is the closest planet yet found. Yes, it's 4 light-years from Earth, just a mere 25 trillion miles away, but travel there may be possible by the end of the century. The planet is called Proxima B, circling a small star called Proxima Centauri, as shown in this animation. It's thought to be about 1.3 times the mass of Earth, probably rocky like the Earth, and possibly warm enough for liquid water.
Proxima Centauri is a red dwarf star, cooler and smaller than our Sun, but notable for having a habitable zone where liquid water could potentially exist, a crucial factor for supporting life. Proxima B resides within this habitable zone, fueling hopes that it might possess the right conditions for life. It has about 1.17 times the mass of Earth, implying that its gravity would be similar, and it completes an orbit around its host star in a mere 11.2 days. However, since Proxima Centauri is a flare star capable of intense bursts of radiation, scientists have long debated whether Proxima B could sustain life or if its surface is subjected to harmful radiation. Despite these uncertainties, Proxima B remains one of the top candidates in the search for life beyond Earth. Its closeness to us and potential habitability make it a central focus of scientific interest. And now, with this latest detection, it appears that Proxima B has once again captured our cosmic curiosity. The James Webb Space Telescope, JWST, launched on December 25, 2021, has transformed our capacity to observe the universe. As the successor to the Hubble Space Telescope, JWST is outfitted with cutting-edge technology designed to peer further into space than any telescope before it. Its primary mission is to study the formation of stars, galaxies, and planets, as well as to investigate the atmospheres of exoplanets, searching for signs of habitability and potential life. What distinguishes JWST is its infrared vision. Unlike Hubble, which mainly captures visible light, JWST can observe in the infrared spectrum, enabling it to detect cosmic objects hidden by dust clouds or too distant for visible light telescopes to see. This ability is crucial in studying exoplanets like Proxima B, where atmospheric composition, surface conditions, and even potential biological markers can be analyzed through spectroscopic techniques. Although JWST was not specifically designed to detect alien life, it possesses tools that make it invaluable in the search for extraterrestrial intelligence. SETI. One of its main objectives is to analyze the atmospheres of distant planets to identify biosignatures, chemical markers such as oxygen, methane, or other compounds that might indicate the presence of life. JWST can also detect technosignatures, which are artificial signals or markers that might be generated by intelligent civilizations. For instance, the presence of certain industrial gases in an exoplanet's atmosphere could suggest technological activity. Moreover, JWST's capability to capture distant radio signals in the infrared spectrum is essential in the hunt for non-natural, potentially artificial signals. Equipped with 4 primary scientific instruments, JWST can capture different aspects of light, allowing it to observe objects across a wide range of the electromagnetic spectrum, especially in infrared wavelengths. These instruments are Near Infrared Camera, NIRCam. NIRCam is JWST's primary imaging device, responsible for capturing the universe in the near-infrared spectrum, 0.6 to 5 microns, just beyond visible light. It plays a vital role in detecting light from the earliest stars and galaxies formed after the Big Bang. NIRCam can take detailed images of distant stars, galaxies, and planetary systems. By observing near-infrared light, it can detect extremely faint objects, including some of the universe's first galaxies. It can penetrate dust clouds, revealing the formation of stars within dense molecular clouds. Additionally, NIRCam can observe exoplanets and their atmospheres by directly imaging these distant worlds or using coronography, which blocks the light from a star to reveal surrounding objects. Near-infrared spectrograph, NIRSpec. While NIRCam provides stunning visuals, NIRSpec is designed to study the spectra of light from distant objects in the near-infrared range, 0.6 to 5 microns. Spectroscopy is crucial in astrophysics, as it allows scientists to decompose light into its component wavelengths and study its interaction with matter. NIRSpec can determine the chemical composition of stars, galaxies, and planetary atmospheres by analyzing absorption and emission lines in the spectra. By measuring redshifts, it can help trace the universe's expansion and the evolution of galaxies over billions of years. It can detect specific molecules like water vapor, methane, and carbon dioxide in exoplanet atmospheres, offering clues about their potential habitability. Mid-infrared instrument, MIRI. MIRI extends JWST's vision into the mid-infrared range, 5 to 28 microns, allowing it to observe much colder and more distant objects. This range is particularly useful for viewing objects obscured by cosmic dust, or those that emit primarily in longer wavelengths, such as newly forming stars, distant galaxies, and planetary systems. MIRI can peer through dust clouds to reveal stars in their early stages of formation. It can detect light from some of the oldest galaxies, providing insights into the formation of large-scale cosmic structures. MIRI is sensitive to cooler objects like planets, moons, and comets, and can determine the chemical makeup of their atmospheres and surfaces. Fine Guidance Sensor, FGS, a near-infrared imager, and slitless spectrograph, NIRIS. The FGS and NIRIS are combined into a single instrument package, but serve different functions. The Fine Guidance Sensor ensures that JWST remains precisely aligned and focused on its target, enabling the telescope to capture sharp, clear images by maintaining stability and eliminating vibrations or pointing errors. The near-infrared imager and slitless spectrograph are used for various scientific observations, including exoplanet detection and characterization. It can study the properties of distant galaxies and stars in the near-infrared range. NIRIS can observe the light from a star as an exoplanet transits in front of it, allowing scientists to study the planet's atmosphere. JWST's instruments work together to provide an unparalleled view of the universe. By capturing images and spectra in both the near-infrared and mid-infrared ranges, it can observe everything from the first stars and galaxies formed after the Big Bang to nearby exoplanets that might harbor life. Each instrument offers complementary data, with NIRCam and MIRI focusing on imaging, while NIRSpec and NIRIS handle spectroscopy for more detailed light analysis. According to recent reports, JWST has picked up an unusual, potentially artificial signal emanating from the direction of Proxima B. Scientists are cautiously optimistic, but are rigorously investigating the signal's nature to determine its origin. The detected signal isn't merely a random burst of cosmic noise. Preliminary analysis suggests it may have patterns or modulations indicative of an intelligent source. However, it's crucial to recognize that many natural phenomena can produce signals that initially appear artificial. Scientists are currently working to rule out possibilities such as satellite interference, background cosmic radiation, or other natural sources. If further analysis confirms that the signal is indeed of extraterrestrial origin, this could mark the first time humanity has received an artificial signal from another civilization. The implications would be nothing short of transformative. As the scientific community awaits further confirmation, the discovery has sparked intriguing possibilities. If this signal truly originates from Proxima B, it raises numerous questions. Could there be intelligent life just 4.24 light-years away? What kind of civilization might exist on Proxima B? What does this discovery mean for future exploration of exoplanets? Although it's too early to definitively say whether this signal is proof of alien life, it undeniably reminds us that we are closer than ever to answering the age-old question: are we alone in the universe? If Proxima B is indeed the signal's source, scientists will delve deeper into understanding the exoplanet's conditions. While it's situated in the habitable zone of Proxima Centauri, flare activity from its parent star could challenge life as we know it. The red dwarf's frequent solar flares could strip away the atmosphere, making Proxima B's surface more hostile. However, some theories suggest that life on Proxima B could adapt to such harsh conditions, or perhaps exist in subsurface oceans or beneath thick atmospheric layers that protect it from radiation. The James Webb Space Telescope has fulfilled its promise of pushing the boundaries of human knowledge. This potential detection from Proxima B could become one of the most significant discoveries in human history. As scientists continue to study the signal, we may be on the brink of finding evidence that we are not alone in the universe. For now, humanity watches with bated breath as JWST helps unlock the cosmos's mysteries, one discovery at a time. Whether the signal from Proxima B proves to be artificial or natural, it is a monumental step forward in our quest to understand the universe and our place within it. Stay tuned, as this might just be the beginning of a new chapter in the history of space exploration. Humanity has always been fascinated by the cosmos, driven by curiosity to explore the unknown and broaden our horizons. For centuries, we've gazed at the night sky, wondering if we're alone in the universe and whether other worlds could host life. With recent technological advances and space exploration, the search for a new, habitable planet has become one of modern science's most compelling quests. But why are we so enthusiastic about this possibility? What would finding such a planet mean for humanity? And if we were to find one, how could we ever reach it? One primary reason we search for a habitable planet is rooted in our species' survival instinct. Earth is currently our only home, but it's not immune to natural or human-made disasters. From climate change to potential asteroid impacts and even the eventual death of the sun, our planet faces risks that could one day make it uninhabitable. Finding another habitable planet could offer humanity a backup, ensuring our species' continuation in the face of existential threats. The search for habitable planets is also driven by an insatiable thirst for knowledge. We want to know how common or rare life is in the universe, and discovering another planet that could support life would provide critical insights into the conditions that make life possible. Are Earth-like planets abundant or exceptionally rare? Does life arise easily under the right conditions, or is it a unique occurrence? Uncovering a new habitable planet could revolutionize our understanding of biology, chemistry, and planetary science. For centuries, the question of whether we are alone in the universe has captivated humanity. Finding a habitable planet, especially one with signs of life, would answer one of our most profound existential questions. Even if the life forms we discover are microbial, it would be a historic moment, indicating that life can emerge elsewhere. The discovery of intelligent extraterrestrial life would be even more astonishing, opening the door to contact with other civilizations and radically altering our perspective on the universe. As a species, humans have always been explorers. From crossing oceans to climbing mountains and sending astronauts to the moon, we've pushed beyond known boundaries to discover what lies beyond. A new habitable planet represents the ultimate frontier, an entirely new world to explore, colonize, and perhaps one day call home. The challenge of reaching and settling a distant world appeals to our sense of adventure and innate drive to push limits. As Earth's population grows and resources become increasingly strained, the idea of finding a second home becomes more appealing. A habitable planet could offer the potential for future colonization, alleviating overpopulation, resource shortages, and environmental degradation on Earth. Discovering a planet with abundant water, fertile soil, and Earth-like conditions could provide an opportunity for humanity to establish new settlements and build a sustainable future. To determine whether a planet could support life, scientists look for criteria known as the habitable zone or the Goldilocks zone. This is the region around a star where conditions are just right for liquid water to exist, a key ingredient for life as we know it. Other factors include the presence of an atmosphere, a stable climate, a magnetic field, and a rocky surface. Planets like Proxima Centauri B have sparked interest because they meet some of these criteria. Proxima B lies in its star's habitable zone, meaning it could potentially have liquid water. However, much more data is needed to confirm whether it could truly support life. While discovering a habitable planet would be groundbreaking, actually reaching it presents enormous challenges. The closest known potential habitable planet, Proxima B, is 4.24 light-years away. In comparison, the Moon is about 1.3 light-seconds away, and Mars is about 12.5 light-minutes away at their closest points. let's examine the main obstacles we would face in trying to reach a distant, habitable planet. The vast distances involved in interstellar travel are one of the biggest hurdles. Even at the speed of light, approximately 300,000 km, it would take 4.24 years to reach Proxima B. However, current space technology is far slower. For instance, the Voyager 1 spacecraft, traveling for over 40 years, is only about 22 light hours from Earth. At that speed, it would take tens of thousands of years to reach the nearest star system. To reach a habitable planet within a human lifetime, we would need to develop technology capable of traveling at a significant fraction of the speed of light, a capability that doesn't exist today. To bridge the immense distances between stars, scientists are exploring advanced propulsion technologies that could make interstellar travel feasible. Some leading ideas include fusion rockets, which could generate far more energy than current chemical rockets, allowing for much faster travel. Fusion reactions could provide the necessary energy to propel a spacecraft toward distant stars. Antimatter engines could produce enormous thrust by annihilating antimatter and matter, releasing vast amounts of energy. Though antimatter production is currently inefficient and costly, light sail technology, like the Breakthrough Starshot initiative, uses powerful laser beams to propel a spacecraft with a large reflective sail, potentially accelerating it to a significant fraction of the speed of light, allowing it to reach Proxima B in about 20 years. Concepts based on Einstein's theory of relativity, such as warp drives, involve bending space-time to move a spacecraft faster than light. While currently theoretical and far from practical, the idea is under exploration by physicists. Even if we overcome distance and propulsion challenges, sustaining life aboard a spacecraft for years or decades would be monumental. This involves developing self-sustaining life support systems capable of providing food, water, and air for extended periods. The psychological and social challenges of prolonged isolation also need addressing. Potential solutions include generation ships, where multiple generations live and die aboard the spacecraft during the journey, or cryo-sleep technology, allowing the crew to be in suspended animation. Assuming we arrive at a new habitable planet, colonizing it would present its own set of challenges. The environment, though habitable, would likely differ vastly from Earth's. Adapting to a new atmosphere, gravity, and ecosystem would require immense preparation. We would need to transport essential resources, build sustainable infrastructure, and ensure the survival of a human colony in an alien setting. Although reaching a habitable planet seems daunting today, technological advances continue to push the boundaries of possibility. With emerging propulsion technologies, ambitious space exploration programs, and a growing understanding of sustaining life in space, traveling to another planet is no longer pure science fiction. It may not happen in our lifetimes, but the dream of interstellar travel and colonization could one day become a reality. And that concludes today's discussion. What do you think this signal could mean for the future of space exploration? Is this the breakthrough we've all been awaiting? If you enjoyed this exploration, be sure to give it a thumbs up, share it with fellow space enthusiasts, and don't forget to subscribe for more mind-blowing updates from the cosmos. Hit that notification bell so you never miss a moment of humanity's journey beyond the stars. Until next time, stay curious, keep gazing upward, and remember, the universe may be far more alive than we ever imagined.
From our perspective, when you look up at the Milky Way, you see all these stars all over the place. So if you're saying flat, like how much height and what are you saying?
Absolutely, there is life elsewhere, and almost certainly intelligent life. It has to be. The odds are just overwhelming.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
After 45 years of exploring the vast expanses of space, NASA's Voyager 1 has made a discovery so astonishing that it has left scientists worldwide in disbelief. This extraordinary finding challenges the very core of our understanding of the universe, unveiling new mysteries and setting the stage for future explorations and breakthroughs. But what exactly has Voyager 1 uncovered, and how will it permanently alter our comprehension of the cosmos?
This is fucking scary. We live on a little speck that's like turning in one of many galaxies, you know?
Embarking beyond familiar frontiers, Voyager 1, the fearless spacecraft launched by NASA in 1977, was intended to journey to the farthest reaches of our solar system and beyond. Originally expected to operate for just 5 years, it has far surpassed all predictions, traveling billions of miles and transmitting invaluable data back to Earth. Now, in a remarkable twist, Voyager 1 has encountered something so extraordinary that it has captivated scientists around the globe. What is this groundbreaking discovery? How might it redefine our understanding of the universe? Together with its twin, Voyager 2, Voyager 1 was launched just 16 days apart in 1977, setting off on an ambitious tour of the outer planets. Their main objective was to study Jupiter and Saturn, capturing unprecedented images and data. Equipped with an array of scientific instruments designed to examine planetary atmospheres, magnetic fields, and moons, Voyager 1 was specifically tasked with a flyby of Titan, Saturn's largest moon, leading to significant insights about its dense atmosphere. As their mission unfolded, both spacecraft continued to provide revolutionary discoveries. Voyager 1 delivered detailed images of Jupiter's Great Red Spot, a colossal storm larger than Earth, and revealed the complex ring system of Saturn. Yet their most remarkable journey was still ahead. In 1980, Voyager 1's path was adjusted to direct it toward interstellar space, marking the beginning of a new chapter in its mission. What mysteries awaited beyond the known stars in the vast emptiness of interstellar space? Voyager 1 was about to find out. In 2012, after 35 years of travel, Voyager 1 made history by becoming the first human-made object to enter interstellar space. This monumental achievement occurred when it crossed the heliopause, the boundary where the solar wind from our sun meets the interstellar medium. This region, beyond the sun's magnetic influence, is a realm filled with cosmic rays, charged particles, and enigmatic forces. By venturing into interstellar space, Voyager 1 began providing invaluable data about this uncharted territory. It measured the density, temperature, and composition of the interstellar medium, offering new perspectives on the vast spaces between stars. The spacecraft's instruments detected a notable increase in cosmic rays and a decrease in solar particles, confirming its passage into this new frontier. An unexplained phenomenon. Recent transmissions from Voyager 1 have unveiled a shocking revelation: the detection of an unknown force or energy field in interstellar space. Picked up by the spacecraft's sensitive instruments, this mysterious phenomenon has astonished scientists everywhere. The data shows unexplained energy fluctuations, suggesting influences beyond our current scientific understanding. Is this a force humanity has never encountered before? The ramifications are immense, with the potential to revolutionize our grasp of the universe. This discovery poses a serious challenge to our existing physical models. Traditional theories rely on gravity, electromagnetism, and nuclear forces to explain cosmic events. However, Voyager 1's findings hint at additional undiscovered interactions. Could our physical laws be just pieces of a much larger puzzle? Scientists are now urgently developing new theories to explain these anomalies, which could lead to monumental advancements in fundamental physics and transform our comprehension of the universe. Grasping this new force could revolutionize the design of future spacecraft and missions. If we can understand how this force interacts with matter and energy, the possibilities are astounding. Innovative propulsion systems might harness this force, enabling more efficient interstellar travel. Future spacecraft could reduce both travel time and energy consumption, bringing the dream of exploring distant stars and galaxies closer to reality. Is this the beginning of a new era in space exploration? One fascinating possibility is that this unknown force is connected to dark energy, the mysterious substance thought to drive the accelerating expansion of the universe. Dark energy, constituting about 68% of the universe's total energy, remains one of cosmology's greatest mysteries. If Voyager 1's discovery is linked to dark energy, it could provide crucial insights into why the universe is expanding at an increasing rate. This understanding might unveil the future of our cosmos, offering answers to profound questions we've only just begun to contemplate. Identifying a new force could trigger a paradigm shift in physics, similar to the impact of quantum mechanics in the early 20th century. What if we are on the verge of rewriting the fundamental laws that govern our universe? Just as quantum mechanics revolutionized our understanding of particles and forces at the smallest scales, this new discovery could reshape our perception of the cosmos. It might lead to the creation of a new branch of physics, integrating this force with existing theories. Such a revolution would not only enhance our scientific knowledge, but also drive technological innovation and advancement. Understanding this mysterious force holds the promise of groundbreaking technologies. What if it could propel humanity into a new era of exploration, expanding our capabilities in unimaginable ways? Imagine harnessing this force for new propulsion systems, allowing spacecraft to travel faster and more efficiently. It might also lead to the discovery of novel energy sources, providing sustainable and powerful solutions for both space exploration and applications on Earth. The potential impact on energy production and usage could be transformative, affecting industries far beyond the realm of space travel. Voyager 1's success highlights the tremendous value of long-term investment in space exploration. Launched over 4 decades ago, it continues to deliver invaluable data that pushes the boundaries of our knowledge. This underscores the importance of sustained commitment to space missions, as they can yield unexpected and transformative discoveries over time. Long-duration missions enable us to explore regions of space otherwise inaccessible, providing insights that shorter missions simply cannot achieve. The discovery of this unknown force raises profound philosophical questions about the nature of reality and the limits of human knowledge. Are there fundamental aspects of the universe that remain hidden from us? What does this mean for our perception of the cosmos and our role as explorers within it? Such inquiries encourage deeper reflection on our quest for understanding and the endless possibilities that lie ahead. The scientific community is actively analyzing Voyager 1's data, formulating new theories and planning potential follow-up missions. Researchers around the world are collaborating to comprehend the implications of this discovery, developing hypotheses and designing experiments to test them. There is a growing interest in sending additional probes into interstellar space to gather more data and further explore these phenomena. This collaborative effort highlights the importance of international cooperation in advancing our understanding of the universe. Far-reaching consequences. A critical question arising from Voyager 1's discovery is whether this mysterious force is localized or universal. Is this phenomenon specific to the region of space Voyager 1 is traversing, or is it a widespread cosmic occurrence? Determining this could drastically reshape our understanding of the universe. If this force is present throughout the cosmos, influencing regions far beyond our current observations, the implications are staggering. This mystery keeps scientists and space enthusiasts eagerly awaiting more data to unravel its secrets. The unknown energy detected by Voyager 1 could have significant implications for the formation of celestial bodies. Might this force play a crucial role in the birth of stars, planets, and black holes? Traditionally, we attribute the formation of these cosmic entities to gravity and nuclear forces, but what if an invisible influence is guiding these processes? This force could be the missing piece in the puzzle of celestial formation, offering a new perspective on how the universe's most magnificent structures come into existence. Imagine a cosmos where the intricate dance of star and planet formation is affected by forces we're only beginning to understand. Voyager 1's journey also highlights the immense challenges of interstellar communication. The spacecraft's signals, delayed by the vast distances, emphasize the difficulties in maintaining contact with distant probes. This delay poses a significant obstacle for future missions, necessitating innovative solutions to bridge the communication gap. Could this newfound force provide a novel method for interstellar communication? Speculating on this possibility, we might envision a future where harnessing this force allows instantaneous communication across the cosmos, revolutionizing our approach to space exploration. The implications of Voyager 1's discovery extend to the search for extraterrestrial life. Could this unknown force influence the development of life elsewhere in the universe? Life as we know it is shaped by the physical laws governing our environment. If these laws are incomplete or vary across the cosmos, what forms of life might emerge under different conditions? This force could create environments conducive to life in ways we've never imagined, opening new frontiers in our quest to find life beyond Earth. This revelation might also pave the way for the long-sought unification of physics, bridging the gap between general relativity, which describes gravitational forces on a cosmic scale, and quantum mechanics, which governs particle behavior at the smallest scales. What if this breakthrough leads to new insights about black holes and matter under extreme conditions? Such unification could unlock the universe's deepest secrets, revealing a cohesive framework that explains everything from galaxy formation to elementary particle interactions. Voyager 1's enduring mission showcases the exceptional engineering foresight and quality behind its design. Launched over 45 years ago, this resilient spacecraft continues to function, sending back data from the edge of interstellar space. Its longevity is a testament to the meticulous planning and innovative technology of its creators. As we celebrate Voyager 1's achievements, we must acknowledge the engineers and scientists whose brilliance made this mission possible. Their work inspires confidence in the potential longevity and success of future space endeavors. Building on Voyager 1's legacy, NASA and other space agencies are planning more advanced interstellar probes to explore deeper into the cosmos. These future missions aim to collect more data, enhance our understanding of the universe, and uncover new phenomena. Equipped with state-of-the-art technology, these probes will venture where no spacecraft has gone before, pushing the limits of human knowledge. What new discoveries await us in the unexplored realms of space? The prospect of these missions ignites the imagination, promising a future rich in exploration and discovery. Transforming our cosmic perspective. Voyager 1's findings may prompt a re-evaluation of gravitational anomalies observed in various parts of space. Some scientists have noted unexpected gravitational behaviors that don't align with our current understanding of mass and distance. Could this unknown force be responsible for these anomalies? Exploring this connection opens up intriguing possibilities. What if this force alters gravitational interactions, leading to new gravitational phenomena? This could revolutionize our understanding of how celestial bodies interact and move within the vastness of space, offering a new lens through which to view cosmic dynamics. The ongoing discoveries from Voyager 1 have the potential to inspire not only scientists, but also artists, writers, and thinkers worldwide. The story of human exploration, embodied by Voyager 1, fuels our collective imagination about the cosmos. Each new finding invites artistic interpretations and philosophical questions about our place in the universe. What narratives will emerge from the discoveries of this pioneering spacecraft? As we share these revelations, they become part of humanity's cultural fabric, igniting a passion for exploration and understanding that transcends generations. Voyager 1's unexpected longevity underscores the serendipity often inherent in scientific discovery. Initially designed for a brief mission, its continued operation has yielded a wealth of unforeseen insights. This phenomenon highlights the importance of embracing unintended outcomes in research. It suggests that some of the most significant breakthroughs occur not through deliberate intention, but through the spontaneous unfolding of events. Such discoveries remind us that the journey of exploration can be as valuable as the destination itself. The implications of Voyager 1's findings extend beyond scientific theories. They challenge our philosophical and cultural viewpoints. Confronted with the existence of an unknown force, we are urged to reconsider our place in the cosmos. What does it mean for humanity if our understanding of the universe is merely a snapshot of a far more intricate reality? This exploration invites deeper contemplation of our existence, the nature of knowledge, and the possibility of phenomena beyond our current comprehension, reshaping the dialogue between science and philosophy. As we face the existence of this mysterious force, we must ask ourselves, what does this mean for humanity's role in the universe? Are we merely observers in a cosmos far more complex than we can imagine? This discovery encourages profound reflection on our reality and our place within this vast, enigmatic universe. Voyager 1's discovery might also inspire new strategies in the search for intelligent extraterrestrial life. If this unknown force interacts with cosmic communications, how might it influence our methods for detecting signals from other civilizations? Researchers could develop technologies to recognize these forces as potential communication modes, opening new avenues for the search for extraterrestrial intelligence, SETI. This perspective may redefine our understanding of how life communicates across the cosmos, pushing the boundaries of astrobiology. The discovery may suggest different behaviors of spacetime in certain regions, challenging our understanding of black holes, wormholes, and the multiverse. What if this unknown force alters the fabric of spacetime, revealing new possibilities for traversing the universe? Imagine navigating through wormholes or perceiving black holes as gateways to other dimensions, reshaping theoretical frameworks and inspiring imaginations in both science and science fiction. Armed with technology from the 1970s, Voyager 1 continues to transmit invaluable data, proving that older technology can still yield cutting-edge insights. Its ability to send information across such immense distances highlights the ingenuity of its design and the robustness of its instruments. Despite rapid technological advancements since its launch, Voyager 1 remains a pioneering vessel, demonstrating that sometimes the wisdom of earlier designs can provide crucial insights in our ongoing quest for knowledge. What lessons might we still learn from past technologies as we advance into the future? Inspiring future generations. Voyager 1's discoveries continue to inspire new space missions and scientific inquiries, sustaining interest in space exploration across generations. Each revelation from this remarkable spacecraft captivates the public, fueling curiosity and a desire to learn more about the cosmos. This enduring interest is vital for securing funding and support for future missions, ensuring the spirit of exploration lives on. As we gaze at the stars, Voyager 1 reminds us of the limitless possibilities beyond our planet, encouraging us to keep pushing the boundaries of what we know. Are we just beginning to uncover the universe's secrets, or is there an entire cosmos awaiting our exploration? Voyager 1's discoveries represent a unique convergence of scientific achievement and public fascination, serving as a powerful catalyst for interest in space exploration. The findings challenge us to think beyond traditional disciplinary boundaries, inviting collaboration among fields like physics, biology, and philosophy. As we grapple with the implications of an unknown force in interstellar space, physicists may seek to explain its origins and interactions, while biologists explore how such phenomena could affect the potential for life beyond Earth. What if the cosmic forces detected by Voyager 1 play a crucial role in shaping biological processes on distant planets? Meanwhile, philosophers might ponder the existential questions these discoveries raise, examining humanity's place in the vast cosmos and the ethical considerations of our exploration. Voyager 1's groundbreaking discoveries could also foster international collaboration in space exploration. As nations face shared challenges in understanding the cosmos, opportunities arise for partnerships that transcend borders. What might be achieved if scientists and engineers from diverse cultures unite to solve complex problems related to space exploration? The collaborative spirit inspired by common goals could lead to innovative technologies, enhanced data sharing practices, and a more comprehensive understanding of the universe. Moreover, international cooperation promotes peace and goodwill among nations, uniting humanity in a collective quest for knowledge. As we face the unknown together, these partnerships could inspire future generations to see themselves as part of a global community dedicated to unraveling the mysteries of the cosmos. Voyager 1 reminds us that exploration is not just a scientific endeavor, but a shared human experience that transcends national boundaries, inviting everyone to join in the adventure of discovery. Could this mysterious force be the key to unlocking the universe's deepest secrets? Share your thoughts in the comments. Don't forget to like this post and subscribe for more astonishing discoveries. Until next time, stay curious and keep exploring.
A snapshot from Mars has rocked the scientific world, changing the way we think about the red planet.
The rover, called Perseverance, survived a perilous high-speed plunge through the Martian atmosphere and made it safely onto the surface of the red planet.
NASA successfully landed its Perseverance rover on Mars.
It's a mission that began with a jaw-dropping descent, beaming back real footage of a Mars landing.
An astonishing image from Mars has sent shockwaves through the scientific community, fundamentally altering our understanding of the red planet. Leading this groundbreaking research is a team of Australian scientists. What is the startling truth behind NASA's Perseverance rover's latest discovery on Mars? In an unforeseen twist, the rover, which was initially searching for signs of ancient life, has now transmitted revolutionary 360-degree footage suggesting the unimaginable: life on Mars. Once considered barren and lifeless, the red planet is now revealing secrets that could transform humanity's grasp of the universe. Join us as we delve into this remarkable discovery and its implications for the future of interplanetary exploration. Chapter 1: 60 Long Years to Mars. The quest for UFOs, NASA's missions to Mars, are a significant chapter in the history of space exploration. These endeavors aim to deepen our knowledge about Mars, assess its potential to have hosted life, and determine if humans could one day inhabit it. The journey began in the 1960s and expanded over the years. NASA dispatched spacecraft to fly by Mars, orbit it, land on its surface, and traverse it with rovers, all in an effort to uncover the mysteries of our enigmatic red neighbor. Initially, the missions involved simply flying past Mars to capture images and gather basic data. But as time progressed, more ambitious projects were undertaken, such as landing the Viking probes to search for life signs and sending the Pathfinder mission along with its small rover Sojourner to examine the Martian terrain more closely. Mars, the fourth planet from the Sun, is cold and arid, resembling a vast desert with a very thin atmosphere. Despite appearing empty and still, Mars undergoes seasonal changes much like Earth. It features polar ice caps, massive canyons, and ancient volcanoes that are no longer active. Evidence suggests that Mars was once warmer and wetter, possibly with enough water to support life. This possibility has piqued NASA's interest, driving the desire to learn even more. By studying Mars, NASA hopes to understand more about the planet's geology, climate, and how it transformed from a world that might have had rivers and oceans into the dry landscape we see today. This ongoing exploration aims to answer the profound question: was there ever life on Mars? At the forefront of Mars exploration are two of NASA's most advanced robotic explorers, the Curiosity and Perseverance rovers. These sophisticated machines are equipped with an array of instruments to study the red planet in great detail. Starting with the Curiosity rover, although it's a bit older, it remains highly significant. Deployed as part of the Mars Science Laboratory mission, Curiosity landed in Gale Crater in August 2012. Its primary objectives were to assess whether Mars could have supported tiny life forms known as microbes, analyze the Martian climate and geology, and gather information to assist future human missions to Mars. Over the years, Curiosity has acted like a detective on Mars, uncovering clues that rivers and lakes might have flowed there long ago. It has detected chemicals that are the building blocks of life and observed seasonal changes in the atmosphere, all suggesting that Mars may have once had conditions conducive to life. Now let's focus on the newer rover, Perseverance. As the younger and more advanced sibling of Curiosity, Perseverance touched down on Mars on February 18, 2021, in a region called Jezero Crater. Scientists believe this area was filled with water billions of years ago. Perseverance's mission is to explore this ancient lakebed for signs that microscopic life might have existed there in the past. It's also tasked with studying the planet's rocks and ancient climate patterns and collecting samples that could be sent back to Earth in the future. But there's more. Perseverance is also testing innovative technologies. One such tool is MOXIE, an experiment aimed at producing oxygen from the Martian atmosphere, which is primarily carbon dioxide. If successful, this could be a game changer for future astronauts, providing breathable air and rocket fuel on Mars. Additionally, Perseverance brought along the Ingenuity helicopter, a small aircraft that has been flying in Mars's thin atmosphere to demonstrate powered flight on another planet. This could revolutionize how we explore Mars from the air, potentially scouting routes for rovers and gathering aerial data. Both Curiosity and Perseverance serve as the eyes and hands of scientists on Mars. They help us understand the planet's composition, climate, and whether it ever had the right conditions for life. These rovers are crucial in unraveling Mars's past, understanding its present, and paving the way for humans to one day set foot on the red planet. By examining Mars up close, we can also gain insights into Earth's evolution and the factors that make a planet habitable. In Mars's vast, silent landscape, a small yet powerful helicopter named Ingenuity has made history. Accompanying the Perseverance rover, Ingenuity wasn't sent to explore the planet directly, but to achieve something unprecedented: fly in Mars's thin atmosphere. This accomplishment is monumental. It marks the first time we've achieved powered flight on another planet, akin to the Wright brothers' first flight, but set on Mars. Despite its small size compared to the rovers, Ingenuity represents a significant leap forward in space exploration. Before its flights, our exploration of Mars was confined to the surface, with rovers moving slowly across the rugged terrain. Ingenuity has demonstrated that aerial exploration is possible, opening up new perspectives of the Martian environment. Imagine being able to soar over obstacles like tall rocks and deep canyons rather than navigating around them. This could make future missions faster and safer. Now let's delve deeper with Perseverance as it embarks on its mission to uncover Mars's mysteries and search for signs of ancient life. Chapter 2. Jezero Crater. Mars's Hidden Lost Secrets. The Perseverance rover mission is NASA's latest journey to Mars, representing a monumental advancement in our quest to understand the enigmatic red planet. This state-of-the-art rover, part of the Mars 2020 initiative, embodies our relentless drive to explore new frontiers and push the boundaries of knowledge. Perseverance's mission is laden with groundbreaking objectives. Its primary goal is to search for evidence of ancient microscopic life forms, a discovery that could revolutionize our understanding of life beyond Earth. Beyond the hunt for life, the rover aims to study Mars's geology and climate, setting the stage for future human exploration. A crucial aspect of its mission is collecting rock and soil samples that could be brought back to Earth for detailed analysis. The rover commenced its journey from Cape Canaveral, Florida on July 30, 2020. It took Perseverance 7 months to traverse the immense distance of 300 million miles to reach Mars. The launch timing was meticulously planned to capitalize on the optimal positioning of Earth and Mars, ensuring the voyage was as fuel-efficient as possible. This mission is far from a routine space expedition. It's a pivotal endeavor that could reshape our understanding of the cosmos and life's potential elsewhere. By scrutinizing the Martian surface and atmosphere, we hope to unearth secrets that have remained concealed for billions of years, offering profound insights into the planet's past and our place in the universe. Perseverance stands as the most sophisticated rover ever dispatched to Mars, building upon the designs and experiences gleaned from its predecessor, Curiosity. This rover is exceptional due to its array of new instruments and features tailored for its challenging mission. Among its standout experiments is MOXIE, designed to generate oxygen from the carbon dioxide-dominated Martian atmosphere. Success in this endeavor could be critical for future astronauts, providing essential life support and fuel for the journey home. In addition to MOXIE, Perseverance is equipped with some of the most advanced cameras and analytical tools ever sent to another planet. This includes instruments like Sherlock and Pixel, which enable the rover to closely examine Martian minerals and search for signs of ancient microbial life. These tools function like supercharged magnifying glasses, allowing scientists to study the building blocks of Martian rocks and dust from millions of miles away. But the rover's exterior is just as impressive. It features a robust heating system to keep its instruments operational during frigid Martian nights, and its wheels are engineered to traverse rocks, dust, and sand without getting stuck. Furthermore, Perseverance didn't embark on its mission alone. It brought along Ingenuity, the tiny helicopter that has made history by achieving powered flight on another planet. Ingenuity's success could transform how we explore space, making it easier to survey Mars from the sky and plan future rover paths. These technological marvels aren't just impressive feats of engineering, they're vital to the mission's goals. By analyzing Martian rocks and soil, Perseverance helps scientists piece together the planet's geological history and assess its past habitability. Every image captured and sample collected brings us one step closer to answering fundamental questions about Mars and the possibility of life elsewhere in the universe. Each instrument aboard Perseverance was carefully selected and designed for this mission. They work in unison to provide scientists on Earth with an unprecedented view of Mars. This mission transcends mere exploration. It's about gathering knowledge that could one day make human habitation of Mars a reality. By understanding the Martian environment and testing technologies like MOXIE, we're laying the groundwork for future astronauts to visit and potentially live on the red planet. The selection of Jezero crater as the landing site was no accident. It was a deliberate choice based on its rich scientific potential and the likelihood of preserving signs of past life. This location is akin to a geological history book because it was once the site where a river flowed into a lake, forming a delta. Imagine a place where water once carried and deposited various soils and rocks, creating layers that tell stories about the planet's past conditions and potential for life. Jezero crater is a treasure trove for scientists due to its diverse terrain and mineral composition, including clays and carbonates. Clays are significant because they can trap and preserve organic materials, indicating life-friendly conditions might have existed. Carbonates can preserve fossilized signs of ancient life and provide insights into Mars's climatic history. This makes Jezero an ideal laboratory for Perseverance to conduct its investigations. The method by which Perseverance landed on Mars is as fascinating as the mission itself. NASA employed an innovative system known as the sky crane to gently lower the rover onto the Martian surface. This wasn't a conventional landing. Initially, the spacecraft entered the Martian atmosphere and deployed a massive parachute to slow its descent. Then, in a remarkable maneuver, a rocket-powered sky crane hovered above the surface and carefully lowered Perseverance on cables. Once the rover touched down, the sky crane detached and flew away to crash land at a safe distance. This sophisticated landing technique, first used with Curiosity but enhanced for Perseverance, allowed NASA to target more scientifically interesting but challenging terrains, like Jezero crater. Previously, landing sites had to be flat and free of obstacles to minimize risks. The success of the sky crane demonstrates how innovative engineering can expand the possibilities for exploration. Immediately after landing, Perseverance transitioned from its landing configuration to operational mode, akin to switching from passenger to driver. One of its first actions was deploying its hazard avoidance cameras. These specialized cameras function like protective eyes, helping the rover detect potential dangers and navigate the Martian landscape safely. They provide essential data to the team on Earth, aiding in planning the rover's movements and activities. These initial images are crucial. They represent Perseverance's first look at its new environment and mark the beginning of its adventure on Mars. They reassure the mission team that the rover is functioning correctly and provide a glimpse of the landscape that will be the focus of its exploration. Perseverance's mission isn't just about gathering data, it's about pioneering the future of human exploration. By testing new technologies and collecting samples for potential return to Earth, the rover is paving the way for astronauts to follow in its tracks. The knowledge gained could be instrumental in addressing the challenges of sending humans to Mars and sustaining them there. Next, join Perseverance as it embarks on a scenic journey through the intriguing and mysterious Jezero crater on Mars. Chapter 3. Mars Up Close. A 360-degree exploration at the edge. NASA's Perseverance rover is making remarkable strides as it navigates and studies the Martian surface. Equipped with advanced instruments, it investigates the planet's rocks, climate, and the possibility of ancient life. One of its most captivating achievements is capturing panoramic images that offer an all-encompassing view of Mars. These images are particularly exciting because they showcase Jezero crater, a region rich with geological features of interest. Perseverance creates these sweeping panoramas by assembling 142 individual photographs into a single seamless image. This technique allows us to see everything from the crater's rim to the distant walls of an ancient river delta. The rover's high-resolution camera can capture details as small as a pencil eraser up close and as large as a car farther away. This level of detail helps scientists reconstruct Mars's geological history and understand its past environments. While previous NASA rovers have taken similar panoramic images, those from Perseverance are unique because they reveal new areas within Jezero crater. These visuals enable scientists and the public alike to virtually explore Mars, fostering a deeper connection with the mission. It's like having a window into another world, revealing the stark beauty and hidden secrets of a planet millions of miles away. As Perseverance traverses the Martian landscape, it encounters a variety of rocks and sediment layers. These discoveries are vital clues in piecing together the history of volcanic activity and water on Mars. The rover's SuperCam instrument, a sophisticated tool combining a camera, laser, and spectrometers, allows it to analyze the chemical composition of rocks from a distance. When Perseverance identifies volcanic rocks, it's a significant find. These rocks indicate past volcanic activity, and studying them helps scientists understand how and when volcanoes erupted on Mars. This information is crucial for reconstructing the planet's geological timeline and assessing its potential to have supported life. The rover also discovers sedimentary rock layers, which are particularly important because they suggest the presence of ancient water. These layers form when water carries and deposits sediments like sand and mud, which over millions of years harden into rock. Each layer is like a page in a history book, telling a story about the environmental conditions at the time it was formed. One of Perseverance's key roles is collecting samples of Martian rocks and soil. The excitement builds when it finds materials like silica and phosphates. Silica is often associated with hot springs on Earth, environments that can support microbial life. Its presence on Mars raises the possibility of similar life-friendly conditions. Phosphates are essential components of DNA and RNA, the molecules that carry genetic information in all known life forms. Finding phosphates suggests that Mars had some of the necessary ingredients for life to originate. These samples are being carefully stored for a future mission that aims to bring them back to Earth. Once here, scientists can perform detailed analyses using advanced laboratory equipment, potentially uncovering evidence of past life or gaining new insights into the planet's history. Let's delve into the ancient past of Mars, exploring the possibility that it once harbored rivers and perhaps even life, challenging our perceptions of this seemingly desolate world. Chapter 4. Mars. Unveiling the trails of ancient water. Recent research and exploration missions have unveiled compelling evidence that Mars once possessed an environment capable of supporting life. This discovery is monumental, altering our understanding of the planet. In this chapter, we examine the signs pointing to a very different ancient Mars. One of the most significant revelations is the strong likelihood that Mars had abundant water, oceans, lakes, and rivers in its distant past. This conclusion is drawn from numerous clues gathered by orbiting satellites, surface rovers, and landers. These findings suggest that Mars was not always the cold, dry world we see today, but may have been warmer and wetter, with conditions suitable for life. Scientists studying Martian rocks, like those analyzed by the Opportunity rover, have observed features that typically form in the presence of water. Layered sedimentary rocks indicate that sediments were deposited by flowing water, much like on Earth. Some formations resemble river deltas, where water spreads out and deposits material, pointing to a history of flowing water on the planet's surface. Additionally, the detection of minerals such as clays and sulfates, which form in watery environments, adds weight to the hypothesis of a wet Martian past. These minerals are crucial because all known life relies on water, making their presence a key indicator in the search for past life. Understanding Mars's ancient environment involves determining how long water existed on the planet, the volume present, and the nature of its climate. Scientists are exploring whether Mars had stable conditions that could support life over extended periods, or if favorable conditions were brief. These questions are challenging, but essential for assessing the planet's habitability. The discovery of signs of ancient water is more than a geological curiosity. It has profound implications for the possibility of life beyond Earth. On our planet, life thrives wherever water is present, from the deepest oceans to microscopic niches. This suggests that if Mars had water, it might also have harbored life, at least in microbial form. This prospect has ignited excitement in the scientific community, particularly among astrobiologists who study the potential for life elsewhere in the universe. The detection of organic molecules on Mars, complex compounds that are the building blocks of life, further fuels this enthusiasm. While these molecules can form through non-biological processes, their presence raises the possibility that life once arose on the red planet. If life did exist on Mars, where did it go? The planet's surface today is inhospitable, with extreme cold and high radiation levels. However, life could persist beneath the surface, where conditions might be more stable and protected. Subterranean environments could provide access to water and nutrients, similar to extremophiles on Earth that thrive in deep underground habitats. Scientists are studying life in extreme conditions on Earth to guide their search on Mars. The concept of a deep Martian biosphere expands the potential habitats where life might exist, both on Mars and on exoplanets orbiting other stars. The implications of finding life on Mars are profound. It would suggest that life is not unique to Earth and could be common throughout the universe. Each discovery about Mars's watery past and potential for life brings us closer to answering one of humanity's most fundamental questions. Are we alone? The search for life on Mars is more than a scientific endeavor. It's a quest to understand our place in the cosmos. With each new piece of evidence, we move closer to unraveling this grand mystery. Chapter 5. A Man-Made Monument. The Mystery of Marshenge. In the vast, enigmatic landscape of Mars, enthusiasts of UFO lore believe they've uncovered a groundbreaking discovery, a circular arrangement of stones resembling Earth's Stonehenge, which they've dubbed Marshenge. This intriguing formation has sparked wild speculation and debate among those fascinated by extraterrestrial mysteries. Some proponents of this theory suggest that these stones are remnants of an ancient Martian civilization. They ponder whether Mars had its own version of Stonehenge, possibly connected to ancient Earth cultures, or even constructed by visitors from our planet in the distant past. This idea captivates the imagination, hinting at a secret history linking Mars and Earth. However, the scientific community approaches these claims with skepticism. Most scientists and researchers specializing in planetary science and astrobiology are unconvinced that Martiangy is evidence of an ancient society on Mars. They caution that overenthusiasm and imaginative interpretations might be leading people to see patterns that aren't actually there. In the Martian deserts, some observers have spotted shapes in NASA's photographs that resemble pyramids or statues with human-like features. These images have fueled stories and theories about a long-lost intelligent society on Mars. Enthusiasts argue that these formations are too precise to be natural, suggesting they are the ruins of buildings or sculptures created by an advanced civilization. But scientists offer alternative explanations. They point out that Mars's landscape has been sculpted by natural processes such as wind erosion, volcanic activity, and the impact of meteorites over billions of years. These forces can create formations that appear artificial but are entirely natural. Moreover, experts highlight the psychological phenomenon known as pareidolia, the tendency of the human brain to perceive familiar patterns, like faces or objects, where none exist. This is the same effect that leads us to see shapes in clouds or the man in the moon. Shadows, lighting, and perspective in photographs can enhance this effect, making random rock formations seem significant. The consensus among scientists is that while Mars is a planet of great interest and mystery, there is no credible evidence supporting the existence of an ancient Martian civilization. Instead, the focus remains on understanding Mars through rigorous scientific investigation, exploring its geology, climate, and potential for past or present microbial life. Is the data from Mars's Perseverance rover a groundbreaking discovery that could change everything we know about life beyond Earth? Or are we merely scratching the surface of a much deeper mystery? As we continue to explore Mars, we invite you to ponder these questions and join us on this journey of discovery. Don't forget to like and subscribe for more cosmic updates and insights into the wonders of the universe.
Today says that growing light pollution is making it harder than ever to see the stars.
Stars adorn our night sky with a captivating glow, but in an unexpected and troubling development, approximately 700 trillion stars have mysteriously vanished. Naturally, this phenomenon has left scientists deeply perplexed, but this was merely the onset of a larger mystery. New entities are now emerging from the depths of space, demanding urgent understanding. Who or what is responsible for the unexplained disappearance of 700 trillion stars in our universe? Could there be a link between these vanishing stars and the unidentified objects originating from deep space? Join us in this video as we explore the enigmatic occurrences unfolding in the cosmos. Scientists are warning that over 700 trillion stars have suddenly disappeared, while something unknown is emerging from the darkness. We'll uncover possible explanations for the disappearing stars and delve into the emergence of this mysterious phenomenon. You might see something resembling a star in an old photograph, only to find it has vanished in subsequent observations. For millennia, humanity has strived to comprehend concepts like science and mathematics, tools that help us decipher our place in the universe, in the fundamental nature of our world, even as its core remains cloaked in enigma. One key principle is that matter cannot simply cease to exist, it must change form. Think about a person disappearing after falling into molten lava. The disappearance is just the final phase of a scientific process. The matter undergoes significant transformation before assuming a new form. Similarly, when a star explodes and seems to disappear, its material disperses throughout the cosmos, persisting in a different state. We mention this because a perplexing mystery has emerged in the far reaches of space, one that currently defies definitive explanation. Stars are disappearing from our night sky. At first glance, this might not seem extraordinary, given the universe's vastness, where a star's sudden disappearance can be due to various reasons, such as reaching the end of its lifespan or being consumed by a massive entity like a black hole. However, what's confounding about this situation is that the disappearing stars aren't isolated cases. They are numerous, totaling in the trillions. Recent observations reveal that over 700 trillion stars have inexplicably gone missing, leaving astronomers baffled by their abrupt absence. While a few stars vanishing might be explainable in such an immense universe, The disappearance of hundreds of trillions, especially those not at the end of their life cycles or under external threats, poses a completely different challenge. Thankfully, a group of dedicated scientists is working tirelessly to solve this cosmic puzzle. Beatrice Villaroel from the Nordic Institute for Theoretical Physics in Sweden offers insight into their mission. Our project, called Vasco, Vanishing and Appearing Sources During a Century of Observations, is our initiative. She adds, "We're fascinated by various disappearing objects, but our ultimate goal is to find a star that has consistently been in the sky throughout human history and recorded data, only to suddenly vanish without a trace. Even our most sophisticated telescopes can't detect any leftovers." It's important to understand that this isn't just a whimsical quest. The Vasco project has been active since 2017 and has attracted significant attention. Villaroel explains that the project has piqued the interest of astronomers from various specialties, including those studying active galactic nuclei, stellar physics, and even SETI scientists, each motivated by different reasons to join. The team recognizes that some aspects of the universe are unpredictable, partly due to our limited capacity to catalog every celestial body with perfect accuracy over such vast distances. Yet they remain hopeful that finding a specific type of star that suddenly disappears could lead to groundbreaking discoveries. Villaroel emphasizes the potential impact. While they are aware of variable stars whose brightness changes over years, they're searching for a star that shifts from consistent stability to complete disappearance, a phenomenon not yet observed. Discovering such an event could open up entirely new areas of physics. You might ask, is it really possible for a star to vanish without any warning? The surprising answer is yes. For example, astronomers had been monitoring a star for about 2 decades until 2019. They were intrigued by its brilliant, crystal blue light. Then, without warning, it was gone. Andrew Allen, a doctoral researcher in astrophysics at Trinity College Dublin, scrutinized the data repeatedly. Because the star was so distant, telescopes couldn't observe it directly. Instead, astronomers looked for the unique signatures that such luminous blue stars imprint on the light from their host galaxies. Shockingly, these signatures had vanished. At the time, the prevailing theory was that the star had gone supernova and turned into a black hole. However, there were no clear signs of a supernova explosion or its aftermath, nor was there evidence of a black hole. Given the interval between observations, it seemed highly unlikely that such a significant event would have gone unnoticed. Astronomer Yair Arkavi from Tel Aviv University highlighted the conundrum. If the star did become a black hole without a supernova, it represents a case of disappearing without the usual fireworks, something astronomers have been trying to understand for a long time. This suggests that some stars might directly collapse into black holes without the dramatic explosion typically expected. Hints of such events date back to 2009, when a star that had captivated many telescopes seemed to be nearing a critical point. Suddenly, it transformed into a black hole before scientists could fully grasp what was happening. While definitive evidence is still lacking, these occurrences have left astronomers searching for explanations. Equally noteworthy is the collaborative effort among various research teams to create detailed catalogs of stars and their properties. These catalogs allow astronomers to compare and analyze stars extensively using online databases. The findings have been both encouraging and astonishing. One researcher mentioned that they found numerous short-lived phenomena that appear in one image and disappear in the next, which constitutes the majority of their discoveries so far. Yet there are still other occurrences that resist immediate explanation. They've investigated some of these fleeting events and ruled out common causes like M-dwarf flares or novas. Building on this, some astronomers believe that the disappearance of these stars could be related to how light travels across the universe's vast distances. Now extend that distance across galaxies. It prompts the question of how we can see anything at all. The reason is that the countless light rays emitted by stars take an incredibly long time to reach us. When they do arrive, they mix with the light from our sun, making them visible in our night sky. The light we see is actually ancient. In the case of our sun, its constant light emission makes it visible to us every day. Yet despite its relative proximity, sunlight still takes about 8 minutes to reach Earth. When considering stars that are light years away, it's clear that the light we observe is extremely old. This is relevant because the seemingly sudden disappearance of stars might be due to the immense age of the light we're receiving. While it appears immediate to us, the star could have died eons ago, and we're only now noticing its absence. This also relates to stars that have long periods of brightness before fading beyond detection. It's a complex idea, and although unproven, these questions are essential for uncovering the truth behind these mysteries. Naturally, some people are drawn to more extreme theories. Among astronomers, one of the most intriguing hypotheses about disappearing stars involves extraterrestrial intelligence. You might wonder how aliens could make stars vanish. The idea isn't that they cause stars to disappear, but that they might be using these massive celestial bodies for their own purposes. Have you heard of the concept of a Dyson sphere? Currently a staple of science fiction, it involves an advanced alien civilization, or perhaps a future human society, building a massive structure around a star. This megastructure would capture and harness the star's energy on a colossal scale, effectively turning it into an enormous power source, or potentially even a weapon. This is reminiscent of the Star Killer base in Star Wars: The Force Awakens, which used a star's energy to destroy entire planets. However, this explanation faces significant challenges. Firstly, we have no concrete evidence of extraterrestrial life. Additionally, constructing a fully operational Dyson sphere around even a small star would require unimaginable time and technological prowess. Extending this idea to over 700 trillion stars as part of a massive galactic project seems highly improbable. Despite this, some people still entertain the possibility. So, where does that leave us? Essentially, we're left with more questions than answers. We know that something unusual is happening in the universe, causing stars to disappear from our sight. This isn't a random occurrence given the large number of missing stars we've detected. The pressing question is, what is causing so many stars to vanish in such a relatively short period? That's why many individuals and organizations across different fields are committed to solving this mystery. Finding the answers could deepen our understanding of the universe. If similar events happen in the future, we'll be better prepared to identify their causes quickly. While the enigma of disappearing stars continues, something new has been detected deep in space. Scientists have discovered enormous voids that surpass our previous expectations, reaching scales that encompass the solar system and even the Milky Way. The universe is filled with voids, vast regions where celestial objects are scarce. One such remarkable void is the Boots Void, also known as the Great Nothing. When you look up at the night sky, it seems uniformly sprinkled with countless stars. However, areas like the Boots Void are dramatically different, containing very few celestial bodies. Essentially, the universe has a unique structure composed of long filaments of dark matter intertwined with galaxies and galaxy clusters, all punctuated by these immense voids. These voids are vast, empty regions lacking in matter. To truly understand the universe, we need to explore these mysterious chasms. The largest known void in the universe is the Bootes Void. This enormous, empty, spherical region spans about 330 million light-years in diameter. That's only about 0.27% of the universe's total diameter, but it's still staggering. Located near the Bootes constellation, this void is approximately 700 million light-years away from us. Initially, only one galaxy was found within it, but a few dozen more have been discovered since. On average, these galaxies are about 10 million light-years apart, a distance 4 times greater than that between the Andromeda Galaxy and Earth. This stark emptiness becomes even more apparent when compared to our local cosmic area, the Virgo supercluster. This smaller region, about 110 million light-years across, contains over 2,000 galaxies, including the Milky Way. To put the scale of this emptiness into perspective, astronomer Greg Aldring noted that if the Milky Way were at the center of the Bootes Void, we wouldn't have known other galaxies existed until the 1960s. In contrast, our Milky Way is accompanied by about 24 nearby galaxies within just 3 million light-years. Given the volume of the Bootes Void, it should theoretically contain around 10,000 galaxies, based on the typical distances between galaxies elsewhere in the universe. Astonishingly, only 60 galaxies have been found in this vast emptiness, making them some of the loneliest galaxies known. The Hubble Space Telescope captured an image of one such galaxy, MCG +01-0, 2-015, a spiral galaxy residing within the Boots Void. The European Space Agency described it as the loneliest galaxy. How it ended up in such isolation is still a mystery. In the image, you can see 3 foreground stars from our own Milky Way. All other points of light are distant background galaxies, resembling tiny organisms in a drop of water. So how do these voids form? Computer models show that smaller, more common voids result from galaxies gravitating toward each other, depleting the surrounding areas. However, this process can't explain the Boots Void because there hasn't been enough time since the universe began for gravity alone to clear out such an enormous space. This brings us back to the Big Bang theory. Most people might imagine the universe expanding uniformly after the Big Bang, with galaxies evenly spreading out. But when we examine the universe on the largest scales, encompassing billions of light years, a more complex structure appears. Let's rewind to the universe's earliest moments. Shortly after the Big Bang, the universe was a dense, extremely hot plasma. Despite being mostly uniform, there were tiny fluctuations, quantum variations in space-time. As the universe expanded, these small differences in matter density became more pronounced. This led to regions of higher and lower matter density on a cosmic scale. Fast forward 13.8 billion years, and we see that these minute early variations evolved into the massive structures we observe today. These structures include enormous walls made up of thousands of galaxies, interconnected by nodes where galaxy filaments meet. These colossal formations stretch across thousands of galaxies and span hundreds of millions of light years. The spaces, or voids, between these galaxy clusters are even larger. These voids aren't completely empty. They're just less dense than regions filled with galaxies. Their matter density is about 1/10 of the universe's average, so they still contain dark matter, gas, dust, stars, and galaxies, but in much smaller quantities. For instance, the giant void contains 17 different galaxy clusters. As the universe continues to expand, these voids, like the Boots Void, will grow even larger. The walls and filaments connecting galaxy clusters will stretch and eventually break apart, leaving only gravitationally bound clusters within the expanding void. As these voids merge, the sheer size of the observable universe becomes even more astounding. Our own position in this vast cosmos is within the Local Group, part of the Virgo supercluster, located on the edge of a massive cosmic void. There's still so much to explore in this immense expanse. So far, astronomers have identified the largest known structure in the universe, a massive void called the supervoid. This supervoid spans an incredible 1.8 billion light-years in diameter and is notable for its extreme emptiness. It provides answers to questions that have puzzled scientists for over a decade, but also raises new ones that could hint at new physics. The amount of cosmic matter, including galaxies and dust, within the supervoid is about 20% less than in regions with typical density. While it's not entirely empty, it feels like a vast, cold wasteland compared to other parts of space. The existence of this supervoid is connected to the discovery of the cold spot, a region observed over 10 years ago for its unusual size and lower temperature than expected based on the cosmic microwave background radiation, the leftover thermal radiation from the Big Bang. Scientists have been searching for a void in this area because as photons travel through an expanding universe, they lose energy and cool when they pass through a void. Confirming this area's extremely low density would help explain why the cold spot exists. This phenomenon occurs because photons convert their kinetic energy into gravitational potential energy as they move from denser regions toward the center of a void. This energy conversion leads to a temperature drop, causing the light to leave with a longer wavelength in a cooler temperature. To find out how many galaxies are in a region about 3 billion light-years from Earth, Istvan Sapudi from the University of Hawaii and his team, including Andras Kovács from Eötvös Loránd University in Budapest, took on the challenge. They used the Pan-STARRS 1 telescope in Hawaii and NASA's Wide Field Survey Explorer satellite. Their research revealed that the cold spot does exist within a large, sparsely populated region. While the structure might not stand out as unique, It's remarkable given the typically uniform distribution of matter at this scale in the cosmos. Unfortunately, only about 10% of the temperature difference between the cold spot and surrounding galaxies can be explained by the supervoid. Returning to the Bootes void, it wasn't until the discovery of dark energy in 1998 that scientists found a possible explanation. Dark energy is a mysterious force that causes empty spaces to expand, as if the entire universe is inflating all at once. Many astronomers believe that these puzzling regions, which reveal the universe's underlying structure, could be key to the next major discovery. There's a growing effort to catalog and map these voids to measure dark energy, gravity, and any unexpected new forces more precisely by statistically analyzing their shapes. Moreover, recent evidence suggests that these vast, nearly empty regions dominating the universe might be accelerating its expansion. This means that dark energy, the mysterious force thought to be pushing the cosmos apart, could be linked to these enormous voids. Essentially, the universe is expanding every day, growing larger with each passing second. This accelerated expansion phase, which seems to have started about 5 billion years ago, remains a mystery to astronomers. Dark energy is just a term we've given to this colossal cosmic puzzle. So what's the connection between dark energy and these cosmic voids? One major reason is that the effects of accelerated expansion aren't noticeable within star systems or galaxies, because the gravitational pull of matter is too strong. Dark energy hasn't caused the Milky Way or our solar system to expand. However, since cosmic voids have very little matter, they're much more susceptible to the influence of dark energy. Therefore, it makes sense to study this accelerated expansion where its effects are most pronounced. A recent study suggests that dark energy might not only be present in voids, but could actually result from them. This leads to the intriguing question of how these vast empty regions might be causing the universe to expand more quickly. Thank you for joining us for another episode on our channel. While you're still here, click on the video on your screen to discover more mind-blowing space content like this one.
Scientists were skeptical that we would ever be able to find these exoplanets because the stars that they orbit are so much brighter than the planets themselves.
The vastness of space has always ignited human curiosity. As our technology advances, so does our ability to peer deeper into the cosmos, uncovering worlds beyond our own solar system. Among these distant worlds is Gliese 832c, an exoplanet that has captured the imagination of scientists and enthusiasts alike. Located just 16 light-years away, Gliese 832ce presents an exciting opportunity to explore the potential for extraterrestrial life in our cosmic neighborhood, understanding exoplanets. Before we can explore the specifics of Gliese 832c, it's important to take a moment to understand what exoplanets actually are. Exoplanets, also called extrasolar planets, are planets that orbit stars located outside of our solar system. The very first confirmed discovery of an exoplanet was made in 1992, marking a major milestone in the field of astronomy. Since that groundbreaking discovery, thousands of these planets have been identified, each one contributing new insights into the vastness and variety of the universe. These exoplanets are incredibly diverse, differing in their sizes, compositions, and the unique ways they orbit their stars. This incredible diversity has provided scientists with a fascinating array of worlds to observe, study, and learn from, revealing just how complex and varied planetary systems can be across the cosmos. The search for exoplanets is motivated by one of humanity's most profound and enduring questions. Are we alone in the universe? This question has fascinated people for centuries, and the discovery of planets beyond our solar system has brought us closer to exploring possible answers. Finding planets that have the potential to support life is considered an important step towards solving this age-old mystery. To do this, scientists carefully study stars and their planets, focusing on those that are located within what is known as the habitable zone. This is the area around a star where conditions are thought to be just right for liquid water to exist on the surface of a planet, one of the essential ingredients for life as we understand it. Introducing Gliese 832c. Gliese 832c is an exoplanet that has attracted significant attention because of its position within the habitable zone of its parent star, This intriguing planet was first discovered in the year 2014 and has been a subject of study ever since. It orbits around a red dwarf star known as Gliese 832, which is a type of star that is much smaller and cooler compared to our own Sun. The star itself is located in the constellation Gliese, a region of the sky that can be observed from Earth. In terms of cosmic distances, Gliese 832 is considered to be relatively close to our planet, making it easier to study than many other distant exoplanets. Gliese 832c is what scientists call a super-Earth, which is a type of exoplanet that has a mass greater than Earth's, but much smaller than the massive ice giants in our solar system, like Uranus and Neptune. Based on current estimates, scientists believe that Gliese 832c is at least 5 times more massive than Earth. This makes it significantly larger and heavier than our planet, but still far smaller than the gas and ice giants. The planet's orbit around its host star is also quite different from Earth's. It completes a full orbit in just 35.7 days, which is much faster than Earth's year-long journey around the Sun, which takes 365 days. This means its year is over 10 times shorter than ours. The habitable zone and potential for life. The concept of the habitable zone plays a central role in the search for life beyond Earth, as it helps scientists identify places where conditions might be suitable for life to exist. This zone, also called the Goldilocks zone, is the area surrounding a star where the temperatures are just right, not too hot and not too cold, for liquid water to exist on a planet's surface. Liquid water is considered one of the most important ingredients for life as we understand it. The orbit of Gliese 832c places it within this special zone, which makes the planet an intriguing candidate for further study to determine its potential to support life. However, being located in the habitable zone does not automatically mean that a planet can support life. There are many factors that play a role in determining whether a planet is truly capable of being habitable. These include the nature of its atmosphere, the presence and strength of its magnetic field, and the level of geological activity on its surface. In the case of Gliese 832c, the planet's larger mass suggests it might have a thicker atmosphere. While this could offer some advantages, it could also result in a strong greenhouse effect. Such an effect could trap too much heat, potentially driving surface temperatures to levels far beyond what is considered suitable for life to exist. Challenges of a red dwarf star. Gliese 832c revolves around a red dwarf star, which brings with it some unique challenges for habitability. Red dwarf stars are smaller and cooler compared to stars like our Sun, but they have their own distinct characteristics that can make conditions harsh for planets orbiting them. These stars, particularly during their early stages of life, can be highly active and unpredictable. They often release powerful stellar flares and emit high levels of radiation, which can pose significant problems for any nearby planets. Over time, this intense activity has the potential to gradually strip away a planet's atmosphere, leaving it exposed and less likely to support life. Moreover, because Gliese 832c orbits much closer to its star than Earth does to the Sun, it might be tidally locked. This means that one side of the planet would always face its star, constantly bathed in perpetual daylight, while the opposite side would remain in constant darkness, never seeing the light of day. Such a unique condition could result in extreme temperature differences between the two hemispheres. The side facing the star could become scorching hot, while the dark side could be freezing cold. These harsh and uneven conditions could make the planet much less hospitable for supporting life as we know it. Atmospheric considerations. The atmosphere of an exoplanet is incredibly important when it comes to determining whether it could be habitable. It serves many critical functions that can directly impact the planet's ability to support life. For example, a thick atmosphere has the ability to move heat around the planet, which can help reduce the extreme temperature differences caused by tidal locking. This means it could make the planet's environment more stable and less harsh. Additionally, a dense atmosphere acts as a protective shield, safeguarding the planet's surface from dangerous radiation coming from its star. In the case of Gliese 832c, if it has an atmosphere that is thick and contains a high amount of greenhouse gases, it might be able to trap and retain enough heat. This would create conditions where liquid water, a key ingredient for life, could potentially exist on its surface. However, without the ability to make direct observations, scientists are limited to relying on models and educated guesses when it comes to understanding the planet's atmospheric composition. These models help provide possible scenarios, but they cannot offer definitive answers. In the future, more advanced telescopes and improved observation methods may open the door to a deeper understanding. These tools could allow scientists to directly detect and thoroughly analyze the atmospheres of exoplanets like Gliese 832c. With this, they could gather the detailed information needed to provide much more concrete and reliable answers. The importance of liquid water. Water is one of the most important factors for life as we understand it. Every form of life on Earth depends on water in some way, making it a key ingredient for sustaining living organisms. The presence of liquid water on the surface of a planet greatly improves the likelihood that some form of life could potentially exist there. Scientists believe that if Gliese 832c has the proper combination of atmospheric conditions and temperatures, there is a chance that liquid water could be present, opening the possibility for life to develop. Some scientific models propose that super-Earths like Gliese 832c might be covered by vast, expansive oceans. These massive bodies of water could provide a stable and consistent environment where life might have the opportunity to develop and thrive over time. Oceans also play an important role in regulating a planet's climate, as they can absorb and distribute heat evenly across the surface. This process helps to prevent extreme temperature differences and creates a more balanced and livable environment. Furthermore, water contributes to a dynamic weather system, enabling the circulation of energy and moisture, which are essential for maintaining a stable planetary ecosystem. Extraterrestrial life possibilities. When thinking about the possibility of life on Gliese 832c, scientists often draw comparisons to extremophiles on Earth. Extremophiles are remarkable organisms that have evolved to survive and thrive in conditions that would be deadly to most forms of life. These include tiny microbes that can live in boiling hot springs, where temperatures soar far beyond what humans could withstand, as well as organisms that inhabit the deep ocean near hydrothermal vents, enduring crushing pressures and searing heat. Some also survive in environments that are highly acidic, where most life would struggle to exist. If life has found a way to exist on Gliese 832c, it could be similarly adapted to survive in conditions that are very different from those we are familiar with here on Earth. The possibility of life does not only apply to advanced or intelligent beings, but also extends to very simple forms, such as microbes or basic multicellular organisms. Intelligent life often captures our imagination and dominates discussions about alien worlds, but even the discovery of the smallest, most basic life form beyond Earth would be a groundbreaking achievement. It would fundamentally change our understanding of the universe, showing us that life is not unique to our planet. Such a discovery would suggest that life has the ability to arise and thrive in many different kinds of environments, far beyond what we currently consider normal or expected. Technological advances and future exploration. Advancements in telescope technology are helping scientists make significant progress in understanding exoplanets, including fascinating worlds like Gliese 832c. With the development of powerful instruments such as the James Webb Space Telescope, which was successfully launched in December 2021, researchers now have tools specifically designed to study the atmospheres of distant planets. These advanced telescopes allow scientists to carefully analyze the light that either passes through a planet's atmosphere or reflects off its surface. By examining this light in detail, they can detect the presence of various gases, such as oxygen, methane, and carbon dioxide. These gases are especially intriguing because they might be linked to biological processes, giving scientists important clues about the possibility of life beyond Earth. In the future, missions designed specifically to focus on finding and studying exoplanets could offer much more detailed and precise information about these distant worlds. Proposals have been made for advanced space-based observatories, as well as interstellar probes, to collect valuable data about nearby exoplanets and their environments. With each step forward in technology, our capability to detect even the most subtle signs of life across the vast expanses of space continues to grow, bringing us closer to uncovering the mysteries of these distant planets. The significance of proximity. One of the most exciting aspects of Gliese 832c is how close it is to Earth in the vastness of space. This exoplanet is located just 16 light-years away, which makes it one of the nearest potentially habitable exoplanets that scientists have identified so far. Its proximity is remarkable when considering the immense distances that usually separate us from other stars and their planets. In astronomical terms, 16 light-years is relatively short, making Gliese 832c an ideal target for observation and in-depth study. Signals or data sent from Earth to this planet would take 16 years to reach their destination, and any response from Gliese 832c would take another 16 years to travel back to us. Although a round trip of 32 years might seem like a long time from our everyday perspective, it is actually quite short when compared to the far greater distances and timescales involved with most other stars and exoplanets that we have discovered across the universe. The relatively short distance of Gliese 832c from Earth also means that if humanity ever develops the technology needed for interstellar travel, this exoplanet could become one of the very first destinations we might choose to explore. Its close proximity to our planet makes it a particularly appealing and practical target for such an ambitious journey, as attempting to reach it would be far more realistic compared to venturing toward planets that are located much farther away in the vast expanse of space. Even if a spacecraft could only manage to travel at a small fraction of the speed of light, it might still be possible for it to reach the Gliese 832 system within a time frame that, although undoubtedly lengthy by today's standards, could still be considered achievable. This journey might unfold over the course of a single human lifetime or, perhaps more likely, across several generations of dedicated travelers, making the dream of reaching this nearby exoplanet a tantalizing possibility for future explorers. The broader implications of discovering life on Gliese 832c would have deeply profound implications for both humanity and the field of science. Such a discovery would fundamentally challenge the way we understand biology, the processes of evolution, and the belief that life on Earth is unique in the universe. It would push us to reconsider many of the assumptions we currently hold about how life begins, how it evolves, and the conditions that allow it to survive. This would lead to a deeper investigation into the processes that drive the existence of life, not only on our planet, but also elsewhere in the cosmos. It would also spark significant and far-reaching questions about how widespread life might be across the universe, and what specific environmental factors or circumstances are necessary for life to emerge and thrive. From a philosophical and cultural perspective, the discovery of extraterrestrial life could bring about a profound shift in how humanity perceives itself and its place within the vast cosmos. It could prompt individuals and societies to deeply question their understanding of existence, their purpose, and the idea of whether life on Earth is truly unique. Such a discovery might have a ripple effect on global thinking, sparking new debates and reflections on the meaning of life and humanity's role in the universe. It could also inspire a transformation in the way nations and cultures interact with one another, encouraging greater unity, cooperation, and mutual curiosity in the shared quest to comprehend this monumental revelation. The awareness that humanity is not alone in the universe could foster a collective effort to explore, learn, and connect with the cosmos, as the human race begins to grapple with the awe-inspiring notion of sharing the seemingly infinite reaches of space with other forms of life. Current limitations and skepticism. Despite the widespread excitement and curiosity surrounding Gliese 832c, it is essential to approach this fascinating topic with cautious scientific scrutiny. While many people are eager to uncover more about this intriguing exoplanet and what it might reveal about the universe, some studies have raised questions about whether it actually exists. These studies suggest that the signals originally interpreted as evidence of a planet could instead be caused by other factors. For example, they might result from the natural activity of the star that Gliese 832c is thought to orbit, or they could be due to noise and inconsistencies in the data that was collected during observations. Because of these uncertainties, scientists have not yet reached a definitive conclusion about whether Gliese 832c is a real planet. Until stronger evidence is gathered and thoroughly analyzed, the true nature and status of this potential exoplanet will continue to be a topic of discussion and debate within the scientific community. Moreover, even if Gliese 832c does exist, the challenges involved in confirming its habitability are enormous and cannot be overlooked. The technology we have today is not advanced enough to provide direct evidence, so scientists have to depend mostly on models and indirect observations to learn about this distant planet. This reliance makes it very hard to reach clear conclusions about the planet's actual conditions. Trying to directly capture images of exoplanets is an especially difficult task, because their host stars produce such intense glare. This bright light easily drowns out the faint light that might reflect from the planet, making it almost impossible to see. On top of that, the immense distances between us and these faraway worlds create yet another significant challenge, making the entire process even more complicated and demanding. A beacon of possibility. In the end, Gliese 832c serves as a reminder of the vast potential that lies beyond our own planet. It encourages us to look up at the night sky with wonder, to invest in scientific endeavors, and to continue seeking answers to the mysteries of the cosmos. The journey to uncover the secrets of Gliese 832c and other exoplanets is not just about finding life elsewhere. It's also about discovering more about ourselves and our place in the universe.
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
On a cool evening in early October, the JWST sent ripples through the global scientific community by detecting a mysterious signal originating from the Andromeda Galaxy, the closest major galaxy to our own Milky Way. For decades, humanity has gazed at the stars, searching for signs of extraterrestrial life or phenomena that defy natural explanations. While we've uncovered countless cosmic wonders, new stars, planets, black holes, and even promising hints of habitable worlds, the discovery of this alarming signal from Andromeda marks a significant turning point in our comprehension of the cosmos. Before we delve deeper, don't forget to like and subscribe for more exclusive updates. Michio Kaku. As soon as the signal was detected, global attention shifted to Michio Kaku, the esteemed theoretical physicist and futurist renowned for his work on string theory and his enthusiastic support for space exploration. Kaku has long argued that the quest to find extraterrestrial life isn't merely a scientific endeavor, but a fundamental question about what it means to be human. Are we truly alone in the universe? The reception of this enigmatic signal from Andromeda might finally start to answer that profound question. The James Webb Space Telescope, a marvel of modern technology, was designed for multiple purposes: to peer deep into the universe's past by observing the earliest light from galaxies formed billions of years ago, to search for exoplanets, and to provide detailed information about the atmospheres of these distant worlds. However, no one anticipated that it would become a beacon for potentially intelligent signals from a neighboring galaxy. Located approximately 2.5 million light-years from Earth, the Andromeda Galaxy is a familiar celestial neighbor, often considered a twin to the Milky Way. Despite this proximity, the vast expanse between our galaxies has made astronomers cautious about expecting any clear signs of intelligent life beyond our own. When the JWST detected the signal, its characteristics immediately raised eyebrows. It wasn't merely electromagnetic radiation from natural stellar sources like pulsars or black holes, which are known to emit repetitive signals. Instead, the frequency and structure of the Andromeda signal suggested something far more intentional. The patterns were too orderly to dismiss as random cosmic noise. To add to the intrigue, the signal repeated at intervals that resembled structured, coded communications. This could potentially indicate the presence of intelligent life capable of creating and transmitting signals across immense cosmic distances. In his public addresses, Kaku explored the possible ramifications of such a signal. Firstly, he emphasized the monumental scientific significance of its detection. If the signal indeed originates from an advanced civilization in Andromeda, it would represent a historic moment for humanity. For centuries, we've looked up at the sky, wondering if we are the sole intelligent species in the cosmos. Discovering evidence of intelligent life in another galaxy would suggest that life isn't a rare occurrence, but perhaps a likely outcome of the universe's natural processes. The Drake equation, long used to estimate the number of intelligent civilizations in our galaxy, might require serious reevaluation. The signal from Andromeda could imply that the universe is teeming with life in ways we hadn't previously imagined. Implications. The implications extend far beyond science and astronomy. They touch on philosophy, sociology, and even theology. For Kaku, the philosophical dimension is unavoidable. Humanity has long operated under the assumption that Earth is unique, and by extension, that we hold a special place in the cosmos. Detecting an intelligent signal from Andromeda challenges this deeply ingrained belief. It raises profound questions about our species' future. Are we on the path to making contact with another civilization? If so, what could that mean for our cultural, technological, and social development? Might we be considered a primitive civilization in comparison? More unsettling is the possibility that the signal comes from a civilization with technology far surpassing our own. Kaku also pointed out that while the signal is thrilling, it carries potential risks. He referred to the well-known concept in the search for extraterrestrial intelligence called the dark forest theory. This theory posits that intelligent civilizations might choose to remain silent to avoid attracting the attention of more advanced, possibly hostile species. If the Andromeda signal is a deliberate message, it could be a plea for help, a declaration of existence, or, more ominously, a warning. If we're receiving their communication, it suggests they either don't subscribe to the dark forest theory or are unaware of its potential dangers. This brings us to an immediate concern. What should humanity do next? Should we respond? Kaku has been an outspoken advocate for caution. Reaching out to a civilization millions of light years away isn't without significant risks. Even if the signal is benign, any reply we send would take millions of years to reach Andromeda. By the time our message arrives, the senders might have evolved beyond recognition or ceased to exist. The vast timescales involved create a paradox where entire civilizations could rise and fall on both sides before any meaningful exchange occurs. The technological achievement of detecting such a signal is itself extraordinary. The JWST wasn't specifically designed to search for extraterrestrial communications, making this discovery even more remarkable. It raises questions about how many other signals we might have missed from more distant galaxies. What if other signals have gone undetected because of our technological limitations? Kaku often stresses the importance of investing in more advanced space observation technologies. While our current tools are impressive, they are just the beginning. To fully comprehend the universe and potentially communicate with distant civilizations, we'll need even more sophisticated telescopes and observational arrays. This discovery could accelerate developments in this direction, prompting space agencies like NASA and private enterprises to expedite their plans for new space-based instruments. However, the detection of this signal also brings up concerns about how the international community will manage such a monumental finding. Until now, space exploration has been largely collaborative, with nations working together to expand our collective knowledge. The prospect of contacting another civilization might, however, introduce a new level of competition. Countries might rush to be the first to decode the signal, claim the prestige of first contact, or leverage the event to assert dominance in space exploration. Kaku cautioned that humanity must avoid repeating past mistakes. History is filled with examples where competition and distrust between nations have led to conflict. He advocates for a unified, collective approach, emphasizing that this discovery belongs to all of humanity, not any single nation or organization. The true nature of the signal remains unclear, and deciphering it will likely take years or even decades of meticulous analysis. There's still the possibility that it could be a natural phenomenon we do not yet understand. Kaku and other scientists remain open to all possibilities, advising against hasty conclusions. However, if this signal is indeed from an intelligent civilization, it could serve as an invaluable learning opportunity. Even if we can't decode the exact message, understanding its structure might provide insights into how other intelligent species communicate. It could introduce us to entirely new concepts in mathematics, language, and science that we haven't even conceived of yet. Moreover, the signal might be a form of communication so advanced that our current knowledge can't fully grasp it. Just as ancient civilizations couldn't detect radio waves because they lacked the necessary technology, the Andromeda signal might be part of a broader, more sophisticated system that exceeds our current capabilities. This possibility fascinates Kaku, suggesting that our civilization is still in its infancy on the cosmic scale. We might be like children overhearing a complex conversation, able to pick out certain words but missing the full context. The future of humanity could depend on developing the tools and intelligence needed to engage with these advanced forms of communication. The journey ahead. One of the most exciting possibilities Kaku raises is that this signal might not be unique. He theorizes that other signals could be hidden within the cosmic background noise, awaiting discovery. Given the vastness of the universe, it's highly unlikely that Andromeda is the only galaxy harboring intelligent life. If one civilization can send a signal, others might have already done so. The detection of the Andromeda signal could be the first in a series of discoveries that radically reshape our understanding of the universe and our place within it. The prospect of receiving a signal from an intelligent species in Andromeda opens a new chapter in human exploration. While the challenges are immense, the potential rewards are equally significant. Kaku's enthusiasm is infectious, but his call for caution is well-founded. The path ahead requires careful thought, balancing ambition with prudence, and maintaining an openness to whatever truths the cosmos may reveal. Whether this signal leads to first contact or simply enhances our understanding of the universe, it marks a pivotal moment in scientific history. It's a moment that will be remembered for generations, igniting the imaginations of dreamers, explorers, and scientists alike. As we stand on the brink of one of humanity's greatest discoveries, private companies and space agencies worldwide might feel inspired or compelled to accelerate their plans. Enterprises like SpaceX, Blue Origin, and others could seize this opportunity to advance their space initiatives, possibly pushing for the development of more sensitive instruments capable of detecting signals from even greater distances. The ultimate aim would be to equip humanity not just to detect signals, but to communicate effectively across intergalactic spaces. Achieving this would require advancements in quantum computing, artificial intelligence, and radio astronomy, as well as breakthroughs in propulsion technology if we ever hope to explore the signal source directly. Another significant consequence of this discovery involves the moral and ethical questions it raises. What rights and responsibilities do we have when interacting with another intelligent species? If the Andromeda signal is a deliberate attempt at communication, it opens up ethical debates that philosophers and scientists have pondered for centuries. Should we respond? If so, how should we go about it? What form would our response take? Intergalactic communication presents unique dilemmas. For one, we don't know the signal's intent. It could be a friendly greeting, an observation, a warning, or something entirely beyond our understanding. There's also the issue of whether humanity is prepared for such a discovery. Historically, encounters between advanced and less technologically developed societies on Earth have often resulted in adverse outcomes for the latter. Could humanity find itself as the less advanced civilization in this cosmic encounter? Kaku frequently points out that our technological sophistication might be rudimentary compared to an intergalactic civilization. What if this civilization is billions of years ahead of us? They might regard us with the same curiosity and detachment that we have when studying microorganisms. This notion raises uncomfortable questions about intelligence and power dynamics in the universe. He often refers to the Kardashev scale when discussing potential hierarchies of civilizations. This scale measures a civilization's technological advancement based on its energy consumption. Currently, humanity is a Type 0 civilization, relying solely on planetary resources. A Type 1 civilization can harness all the energy of its home planet, a Type 2 can utilize the energy of its entire star, and a Type 3 can command the energy of an entire galaxy. If the Andromeda signal comes from a civilization that's Type 2 or 3, it challenges us to consider how such an advanced society might perceive us. The technologies they possess, artificial intelligence, faster-than-light communication, perhaps even interstellar travel, could defy our current understanding of physics. While this could lead to a renaissance of scientific discovery on Earth, it could also provoke fear and paranoia. History shows that fear of the unknown can lead to irrational actions. On a cultural level, this discovery could prompt a period of deep introspection. It forces us to confront existential questions that have lingered for millennia. Why do we exist? What is our role in the universe? Are we meant to join a larger galactic community, or are we destined to remain isolated observers? If the signal originates from an intelligent species, it might offer insights into how another civilization has addressed these fundamental questions. They may have overcome challenges like war, inequality, and environmental degradation. providing a model for how humanity might evolve. Conversely, their experiences could serve as a warning about the pitfalls of unchecked technological progress. Political implications. Religious and spiritual communities around the globe are likely to feel the impact of this discovery profoundly. Many belief systems posit that humanity holds a unique place in the universe, possibly as the sole intelligent life. The possibility of other intelligent beings, especially ones far older and more advanced, could challenge foundational doctrines. How will different religions reconcile the existence of extraterrestrial intelligence with their teachings? This could lead to a crisis of faith for some, while others might find that it expands their understanding of the divine. The discovery also opens up philosophical debates about consciousness and the soul. If other intelligent beings exist, what is the nature of their consciousness? Do they possess self-awareness, emotions, a sense of morality similar to ours? Or are they fundamentally different in ways we can't yet comprehend? Politically, the Andromeda signal could have far-reaching consequences. Governments worldwide would likely scramble to interpret the signal and control the narrative. International organizations like the United Nations might become forums for intense debate about the appropriate course of action. Should humanity unite to decode the message and decide on a response? Or will nations pursue their agendas? The discovery could either foster unprecedented global cooperation or exacerbate existing tensions, particularly among superpowers with advanced space capabilities. Countries might compete to be the first to decode the signal, hoping to gain technological or strategic advantages. This could lead to a new kind of space race, not just about exploration, but also about securing potential benefits from any new technologies derived from the signal. National security concerns would also come into play. Governments would need to consider the risks of responding. Could acknowledging the signal make us vulnerable to hostile extraterrestrial forces? The militarization of space, already a concern, could accelerate as nations invest in defense systems against hypothetical threats. National security implications. The economic implications are equally significant. The burgeoning space economy could receive a substantial boost as both governments and private companies invest in technologies to detect, decode, and possibly respond to extraterrestrial communications. New industries could emerge, focusing on interstellar communication technologies, advanced propulsion systems, and more sophisticated space exploration tools. Intellectual property resulting from decoding the Andromeda signal could become a highly valuable asset. Universities, research institutions, and private companies might engage in fierce competition over patents and proprietary technologies. This could spur innovation, but also lead to legal and ethical disputes over ownership and access to these advancements. However, this rapid expansion into space brings risks. There could be unintended consequences like environmental harm to other celestial bodies or increased militarization of space. Ethical considerations about exploiting extraterrestrial environments would become more pressing. Beyond these immediate concerns, the signal invites us to ponder the nature of life and intelligence in the universe. What kind of intelligence could have sent this signal? It's possible that the signal doesn't come from biological beings, but from artificial intelligence created by a civilization that may no longer exist. Kaku and other futurists have speculated that advanced civilizations might reach a point where they can upload their consciousness into machines, achieving a form of immortality. If the signal comes from such a machine intelligence, it challenges our understanding of life itself. Another intriguing possibility is that the signal represents an attempt at interstellar diplomacy. Perhaps a civilization in Andromeda is part of a larger coalition of intelligent species spread across the universe, and this signal is an invitation to join them. This concept, a staple in science fiction, edges closer to reality with this discovery. However, integrating into a galactic community poses its own challenges. How would humanity, with its myriad political, religious, and cultural differences, present a unified front? Would we be accepted as equals, or might we find ourselves subordinate to more advanced species? As the world grapples with the implications of this signal, the event continues to push the boundaries of our knowledge and imagination. Each day brings new discussions, research avenues, and speculative theories. Scientists, technologists, and thinkers are deeply engaged in contemplating the long-term effects of this potentially transformative moment. The complexity of the signal and the vast array of possible explanations force us to reevaluate our assumptions about our place in the universe. One of the most immediate questions is what kind of intelligence could have sent this signal? Our understanding of intelligence is limited, based largely on our own species. We tend to project human cognitive and social traits onto hypothetical alien civilizations. But what if the intelligence behind the Andromeda signal is so different from ours that it's almost incomprehensible? This possibility is one of the most fascinating aspects of the discovery. If the signal is artificial, it might represent a form of intelligence operating under entirely different biological, cognitive, or technological frameworks. Communicating with such an entity would be an unprecedented challenge. The diversity of life on Earth provides only a hint of what's possible. Even among Earth's species, there are vastly different ways of processing information and perceiving reality. Dolphins use echolocation, bees communicate through complex dances. The intelligence behind the Andromeda signal might utilize forms of communication that are entirely alien to us, perhaps involving dimensions of physics we have yet to discover. This leads to the crucial task of language and decoding. Historically, breaking language barriers between human cultures has been a significant hurdle. Decoding a message from another species, potentially from another galaxy, presents an exponentially greater challenge. Scientists like Kaku speculate that we might start by identifying universal constants, such as mathematical principles or physical laws, as a common language. For example, sequences of prime numbers or patterns like the Fibonacci sequence could serve as initial points of connection, given that mathematics is considered a universal language. However, even this assumes that the other intelligence perceives the universe in a way that's compatible with our own understanding. Our efforts to decode the signal will likely rely heavily on advanced artificial intelligence and machine learning technologies. The complexity of the patterns might be beyond human cognitive capabilities, necessitating sophisticated algorithms to identify and interpret potential meanings. Training AI to simulate various alien cognitive models could expand our ability to make sense of the data. As we undertake this monumental task, the question of whether to respond looms large. Some experts advocate for caution, suggesting we should focus on understanding the message fully before deciding on any course of action. Others argue that the chance to engage with an advanced civilization is too significant to delay, despite the risks. The decision to respond ties back to the issue of trust. We cannot assume that an extraterrestrial civilization shares our values or even has a concept of values that we can recognize. Establishing common ground might be one of humanity's greatest challenges. Kaku and others suggest looking to our history for guidance, but human encounters between disparate societies have often resulted in exploitation and conflict. This historical context underscores the need for a cautious and ethical approach. This is where the idea of cosmic humility becomes vital. Recognizing that we may not be the most advanced beings in the universe can be both humbling and inspiring. It opens the door to learning and growth, potentially accelerating our scientific and technological development. The Andromeda signal may also compel us to reassess our notions of progress. If we encounter a civilization that has evolved along a different path, perhaps prioritizing sustainability or social harmony over technological dominance, it could challenge our assumptions about what it means to advance. Simultaneously, the signal acts as a mirror, reflecting our unresolved issues back at us. Global challenges like climate change, inequality, and geopolitical tensions demand our attention. How can we aspire to engage with an advanced alien civilization when we're still grappling with problems here on Earth? The discovery might serve as a catalyst for uniting humanity to address these pressing concerns. In terms of international relations, crafting a response to the signal would require unprecedented global cooperation. A message to another galaxy represents all of humanity, necessitating a collective effort to define what we want to communicate about ourselves. The cultural impact of the discovery is immense. It could inspire a new wave of creativity across art, literature, and media as we explore what it means to be human in a universe potentially filled with life. Educational systems might adapt to include new disciplines focused on astrobiology, extraterrestrial communication, and interstellar diplomacy. If you found this discussion intriguing, please like and subscribe for more insights. We'd also love to hear your thoughts. What do you think the signal from Andromeda could be? Share your ideas in the comments below. Thank you for joining us, and we'll see you next time. The night sky is poised for a dramatic change as Antares, a red supergiant 700 times larger than our Sun, nears the end of its life. On the verge of a supernova, its explosion could outshine even Betelgeuse and rival the brightness of our entire galaxy. As we await this cosmic event, one question remains. What will happen when this stellar giant finally erupts?
So imagine looking on the horizon and sunrise is half the sky. Okay, that would be terrifying.
Is a supernova, first of all?
A supernova is an exploding star.
They are among the biggest explosions of radio energy in the entire universe.
Betelgeuse or Betelgeuse, it's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
Observable supernovae within our galaxy are exceedingly rare. The last recorded instance occurred centuries ago, making the potential explosion of Antares a once-in-a-lifetime spectacle. This impending celestial display offers astronomers and space enthusiasts a unique opportunity to witness cosmic history unfold before their eyes. As we embark on this journey through the cosmos, we'll explore the far-reaching impacts of this stellar explosion. From the creation of heavy elements to the potential formation of neutron stars or black holes, the aftermath of Antares supernova will shape the fabric of our galaxy for eons to come. Join us as we unravel the mysteries surrounding this cosmic ticking time bomb and its profound implications for our understanding of the universe. Antares, the red giant's final act. In the vast expanse of our night sky, one star stands out as a true celestial giant. Antares, a red supergiant located approximately 604 light-years from Earth, is a cosmic behemoth that captures the imagination of astronomers and stargazers alike. This stellar titan boasts a diameter roughly 700 times that of our Sun, making it one of the largest known stars in the universe. To put its size into perspective, if Antares were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This colossal star is not only enormous, but also incredibly bright, ranking among the top 20 brightest stars visible from Earth. Its prominent position in the constellation of Scorpius makes it a familiar sight to many observers of the night sky. Antares' impressive luminosity, however, is not constant. The star's brightness fluctuates, with its apparent magnitude varying between 0.88 and 1.16. These variations, while subtle to the naked eye, are a testament to the dynamic nature of this stellar giant. As Antares pulsates and shifts, it provides astronomers with valuable data about the life cycles of massive stars. But what makes Antares truly fascinating is its current stage of life. This red supergiant is nearing the end of its stellar journey, having exhausted its primary fuel source of hydrogen. In the core of Antares, a complex dance of nuclear fusion is taking place. The star is now fusing progressively heavier elements, a process that will ultimately lead to its dramatic demise. This final act in Antares' life is a precursor to one of the most spectacular events in the universe, a supernova explosion. As the star continues to fuse heavier elements, it's building up to a cosmic crescendo that will outshine entire galaxies. When Antares finally explodes, it's expected to become so bright that it could rival the combined luminosity of every other star in the Milky Way galaxy. Imagine looking up at the night sky and seeing a single point of light as bright as our entire galaxy. This is the potential future that awaits us when Antares goes supernova. The explosion will be visible even in broad daylight, turning night into day for a brief period. It's an event that would be remembered for generations, much like the supernovae recorded by ancient astronomers centuries ago. The impending explosion of Antares offers a unique opportunity for scientific study. By observing this nearby supernova, astronomers hope to gain unprecedented insights into the death throes of massive stars. The data collected from this event could revolutionize our understanding of stellar evolution and the processes that create the heavy elements essential for life in the universe. Interestingly, the name Antares itself holds a clue to the star's appearance and historical significance. Derived from ancient Greek, the name means anti-Ares, or rival of Mars. This moniker was given because the star's reddish hue bears a striking resemblance to the red planet. Ancient astronomers noted this similarity, leading to Antares being sometimes referred to as the heart of the scorpion in its host constellation. The connection between Antares and Mars goes beyond mere appearance. It speaks to the human tendency to find patterns and relationships in the night sky, a practice that has been central to navigation, timekeeping, and mythology for thousands of years. This celestial rivalry between Antares and Mars has been recognized by various ancient civilizations, each incorporating the star into their own cosmic narratives. The anatomy of a supernova. As we venture deeper into the mysteries of stellar evolution, we encounter one of the most awe-inspiring phenomena in the universe, the supernova. This cosmic spectacle represents the grand finale of a massive star's life, a celestial fireworks display that outshines entire galaxies. But what exactly is a supernova, and why does it captivate astronomers and casual stargazers alike? A supernova is, in essence, the largest observable explosion from Earth. It occurs when a star, having exhausted its nuclear fuel, can no longer support its own weight. The resulting collapse triggers a catastrophic explosion that releases an enormous amount of energy and light. This cosmic cataclysm is so bright that it can be seen across vast distances, sometimes even visible to the naked eye during daylight hours. The sheer scale of a supernova explosion is difficult to comprehend. During this cosmic event, material is expelled at incredible speeds, reaching several % of the speed of light. To put this into perspective, imagine a mass several times that of our sun being ejected into space at velocities approaching 30 million miles per hour. This violent expulsion of stellar material creates shock waves that ripple through the surrounding interstellar medium, shaping the cosmic landscape for light years around. But the supernova's influence extends far beyond its immediate vicinity. These stellar explosions play a crucial role in the cosmic ecosystem, acting as factories for heavy elements. The intense heat and pressure during a supernova create conditions that forge elements heavier than iron, which are then scattered throughout space. This process enriches the interstellar medium with the building blocks necessary for the formation of new stars, planets, and even life itself. The aftermath of a supernova is equally fascinating. Depending on the initial mass of the star, the explosion can result in one of two exotic outcomes: a neutron star or a black hole. Neutron stars are incredibly dense objects, where the mass of a sun is compressed into a sphere roughly the size of a city. Their gravity is so intense that a teaspoon of neutron star material would weigh billions of tons on Earth. Black holes, on the other hand, represent an even more extreme outcome. These cosmic enigmas are regions of space where gravity is so strong that nothing, not even light, can escape. They continue to be a source of fascination for scientists and the public alike, challenging our understanding of the fundamental laws of physics. The frequency of supernovae in our galaxy adds another layer of intrigue to these cosmic events. It's estimated that between 2 to 12 stars go supernova in the Milky Way each century. Yet despite this relatively high occurrence rate, no supernova has been observed in our galaxy for several centuries. This statistical anomaly suggests that we are overdue for such an event, heightening the anticipation among astronomers for the next galactic supernova. The last recorded supernova in our galaxy was observed by Johannes Kepler in 1604, more than 4 centuries ago. Known as Kepler's supernova, it was visible to the naked eye for over a year, rivaling the brightness of the planet Mars. The long gap since this last observed event underscores the rarity of visible supernovae in our cosmic neighborhood and highlights the potential significance of Antares' eventual explosion. A celestial companion, Antares B. While Antares steals the spotlight in our cosmic narrative, it's not a solitary player in this stellar drama. Hidden in plain sight is Antares B, a lesser-known companion star that adds another layer of intrigue to this celestial system. Described as a little spark of glittering emerald, Antares B is a bluish-white star that orbits its giant red counterpart. The relationship between Antares and Antares B forms what astronomers call a binary star system. These cosmic partnerships are more common than one might think, with many stars in our galaxy existing in pairs or even larger groups. The dance between these stellar companions can have profound effects on their evolution and ultimate fate. In binary systems like Antares, the gravitational interaction between the stars can significantly influence their life cycles. This cosmic tango can alter the rate at which stars age, affect their mass loss, and even determine the nature of their eventual demise. The presence of Antares B adds an extra variable to the equation when considering the future supernova of Antares. The study of binary star systems provides astronomers with valuable insights into stellar evolution. By observing how these paired stars interact over time, scientists can refine their models of stellar life cycles and better predict the outcomes of various stellar scenarios. This knowledge is crucial for understanding not only individual stars, but also the broader cosmic processes that shape our universe. One particularly intriguing example of a binary system on the brink of a stellar explosion is T Corona Borealis. This system consists of a red giant star and a white dwarf, locked in a cosmic embrace that's about to reach a dramatic climax. Astronomers predict that T Corona Borealis will experience a nova explosion between now and September 2024, offering a rare opportunity to witness a stellar outburst in real time. A nova, while less powerful than a supernova, is still a spectacular cosmic event. In the case of T Corona Borealis, the anticipated nova is expected to be visible to the naked eye, potentially rivaling the brightness of Polaris, the North Star. This means that for a brief period, observers on Earth will be able to see what appears to be a new star blazing in the night sky. The last recorded eruption of T Corona Borealis occurred in 1946, making the upcoming event a significant astronomical occurrence. Observers can expect to see this temporary new star with the naked eye for at least a couple of days, and it will remain visible through binoculars for about a week. This provides a unique window for both professional astronomers and amateur stargazers to study and appreciate the dynamic nature of our universe. The rapid nature of nova events adds to their allure. As one researcher notes, this new star will reach its peak brightness within 24 hours of the nova explosion. This sudden burst of light serves as a stark reminder of the ever-changing nature of our cosmos, where stellar dramas unfold on timescales both impossibly long and surprisingly short. While the T Corona Borealis nova and the potential Antares supernova are different in scale, they both highlight the dynamic and sometimes explosive nature of binary star systems. These cosmic partnerships can lead to some of the most energetic events in the universe, shaping the very fabric of space around them. The cosmic ecosystem, life after supernova. In the wake of a supernova, the universe enters a phase of cosmic renewal. These stellar explosions are not merely destructive events, but rather catalysts for creation on a grand scale. Supernovae play a pivotal role in the cosmic ecosystem, acting as celestial factories that forge and distribute heavy elements throughout the universe. The process begins in the final moments of a massive star's life. As the star exhausts its nuclear fuel, it undergoes a catastrophic collapse followed by an explosive rebirth. This violent event creates conditions of extreme heat and pressure, enabling the formation of elements heavier than iron. These elements, such as gold, silver, and uranium, cannot be produced through the normal fusion processes that occur during a star's lifetime. In the midst of this cosmic crucible, these newly formed heavy elements are violently expelled into space. The explosion disperses material several times the mass of the Sun at incredible speeds, enriching the surrounding interstellar medium. This enriched material becomes the raw material for future generations of stars and planets. The elements produced in supernovae are essential for the formation of planets and life as we know it. Carbon, oxygen, and nitrogen, the building blocks of organic compounds, are among the elements scattered by these cosmic explosions. Iron, crucial for the formation of rocky planets like Earth, is also a product of supernovae. In a very real sense, we are all made of stardust, forged in the fires of ancient stellar explosions. This cosmic distribution of elements illustrates the interconnectedness of stellar and planetary evolution. The death of one star paves the way for the birth of new celestial bodies, creating a continuous cycle of cosmic renewal. It's a testament to the dynamic nature of our universe, where destruction and creation are intricately linked. Despite the crucial role supernovae play in cosmic evolution, predicting which stars will go supernova remains a significant challenge for scientists. The difficulty lies in determining the precise stages of fusion occurring within a star's core. Many stars, including red supergiants like Antares, may have millions of years left before they reach their explosive finale. The complexity of stellar evolution makes it challenging to pinpoint exactly when a star will exhaust its nuclear fuel. Factors such as mass, composition, and even interactions with companion stars can influence a star's lifespan and eventual fate. This uncertainty adds an element of cosmic suspense to the study of massive stars, as astronomers watch and wait for signs of impending stellar demise. However, the study of red supergiants like Antares provides valuable insights into the conditions that lead to supernova events. These massive stars are in a critical phase of stellar evolution, having exhausted their primary hydrogen fuel and now fusing heavier elements. By observing the behavior and characteristics of stars like Antares, astrophysicists can refine their models of stellar evolution and improve their ability to predict future supernovae. The data gathered from studying red supergiants helps scientists understand the internal processes that occur in the final stages of a massive star's life. This knowledge is crucial for developing more accurate models of stellar evolution and supernova mechanisms. As one astrophysicist noted, supernovae are indeed fascinating phenomena like no other, and they serve as a reminder of the dynamic processes that govern the universe. Each observation of a red supergiant like Antares adds to our understanding of these cosmic giants. The variations in brightness, temperature, and spectral characteristics provide clues about the internal furnaces of these stars. This information, combined with theoretical models, allows scientists to piece together the puzzle of stellar evolution and supernova prediction. The study of supernovae and their progenitor stars has far-reaching implications beyond astronomy. It touches on fundamental questions about the origin of elements, the formation of planets, and the conditions necessary for life to emerge in the universe. By understanding these cosmic processes, we gain insight into our own origins and place in the vast cosmic tapestry. Witnessing cosmic history. The universe unfolds its secrets to us in rare and spectacular events, and few are as awe-inspiring as a supernova in our own galaxy. These cosmic explosions, marking the dramatic end of a star's life, are not just visually stunning, but also scientifically invaluable. Yet, despite their significance, observing a supernova in the Milky Way is an exceptionally rare occurrence. Consider this: the last recorded supernova in our galaxy was observed over 4 centuries ago. In 1604, Johannes Kepler documented a stellar explosion that was visible to the naked eye for more than a year. This event, known as Kepler's supernova, rivaled the brightness of Mars at its peak. Since then, our galaxy has been notably quiet, at least from our earthly vantage point. The scarcity of observable supernovae in our cosmic neighborhood makes the potential explosion of Antares all the more significant. If this red supergiant were to go supernova in our lifetime, it would offer an unprecedented opportunity for scientific study and public engagement with astronomy. However, the apparent lack of supernovae in our galaxy doesn't mean these cosmic events are not occurring. Modern technology has revolutionized our ability to detect and study supernovae, even if they're not visible to the naked eye. Advanced telescopes and sophisticated detection methods allow astronomers to observe supernovae in distant galaxies, expanding our understanding of these cosmic phenomena. These technological advancements have opened new avenues for research. Astronomers can now study supernovae across vast cosmic distances, comparing data from multiple events to refine our models of stellar evolution and explosion mechanisms. This wealth of information helps scientists piece together the complex puzzle of how stars live and die. The potential future observation of Antares supernova would be a game changer in this field. Being relatively close to Earth at about 604 light-years away, Antares offers a unique opportunity for detailed study. Its explosion would provide unprecedented data on the death throes of a massive star, allowing scientists to test and refine their theories in real time. Imagine the wealth of information that could be gathered from such an event. Astronomers would be able to track the supernova's evolution from its earliest stages, observing changes in brightness, temperature, and composition as the explosion unfolds. This data would be invaluable for understanding the physical processes that drive stellar explosions and the formation of neutron stars or black holes. Moreover, the explosion of Antares would offer insights into the production and distribution of heavy elements in the universe. Supernovae are cosmic forges, creating elements heavier than iron and scattering them across space. By studying Antares supernova, scientists could gain a better understanding of how these elements are formed and dispersed, shedding light on the chemical evolution of our galaxy. The public impact of such an event would be equally significant. A supernova visible to the naked eye would capture global attention, potentially inspiring a new generation of astronomers and space enthusiasts. It would provide a rare opportunity for people worldwide to witness cosmic history firsthand, fostering a deeper appreciation for the dynamic nature of our universe. However, it's important to note that predicting when Antares will go supernova remains challenging. While the star is in the later stages of its life, it could still have thousands or even millions of years left before it explodes. This uncertainty underscores the need for continued observation and study of Antares and other potential supernova candidates. In the meantime, astronomers continue to refine their methods for detecting and studying supernova across the cosmos. Each observation, whether of a distant galaxy or a nearby star, adds to our understanding of these cosmic events and their role in shaping the universe. A new chapter in cosmic understanding. The study of Antares and supernovae opens a new chapter in our cosmic understanding. These stellar explosions not only distribute heavy elements crucial for planet formation, but also provide insights into the life cycles of massive stars. As astrophysicists refine their models, each observation of red supergiants like Antares brings us closer to predicting future supernovae. This ongoing research enhances our comprehension of the universe's dynamics and our place within it. The potential explosion of Antares represents a pivotal moment in astronomy. It offers a rare opportunity to witness cosmic history and advance our knowledge of stellar evolution. As we continue to explore the night sky, we're reminded of our deep connection to the stars. The cosmic drama unfolding above us is not just a distant spectacle, but a fundamental part of our own story. In the words of one astronomer, supernovae serve as a reminder of the dynamic processes that govern the universe. The night sky is on the brink of a dramatic transformation as Antares, a red supergiant star 700 times larger than our Sun, approaches the end of its life and teeters on the verge of a supernova. Its impending explosion could outshine even Betelgeuse and rival the luminosity of our entire galaxy. As we anticipate this cosmic event, one pressing question remains. What will occur when the stellar giant finally erupts? Imagine gazing at the horizon and witnessing a sunrise that fills the entire sky. That would be terrifying if caused by a supernova. First off, a supernova is an exploding star and ranks among the most massive releases of radiant energy in the entire universe. Betelgeuse is a red giant star. If placed where our Sun is, it would extend out to the orbit of Jupiter. It's enormous, highly unstable, and on the brink of explosion. Observable supernovae within our galaxy are exceedingly rare. The last recorded instance happened centuries ago, making the potential explosion of Antares a once-in-a-lifetime spectacle. This upcoming celestial display offers astronomers and space enthusiasts a unique chance to witness cosmic history unfold before their very eyes. As we embark on this journey through the cosmos, we'll delve into the far-reaching impacts of this stellar explosion, from the creation of heavy elements to the potential formation of neutron stars or black holes. The aftermath of Antares supernova will shape the fabric of our galaxy for eons to come. Join us as we unravel the mysteries surrounding this cosmic ticking time bomb and its profound implications for our understanding of the universe. Antares, the red giant's final act. In the vast expanse of our night sky, one star stands out as a true celestial giant, Antares, a red supergiant located approximately 604 light-years from Earth. This cosmic behemoth captures the imagination of astronomers and stargazers alike. This stellar titan boasts a diameter roughly 700 times that of our Sun, making it one of the largest known stars in the universe. To put its size into perspective, if Antares were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This colossal star is not only enormous, but also incredibly bright, ranking among the top 20 brightest stars visible from Earth. Its prominent position in the constellation of Scorpius makes it a familiar sight to many night sky observers. Antares' impressive luminosity, however, is not constant. The star's brightness fluctuates, with its apparent magnitude varying between 0.88 and 1.16. These variations, while subtle to the naked eye, testify to the dynamic nature of this stellar giant. As Antares pulsates and shifts, it provides astronomers with valuable data about the life cycles of massive stars. But what makes Antares truly fascinating is its current stage of life. This red supergiant is nearing the end of its stellar journey, having exhausted its primary fuel source of hydrogen. In the core of Antares, a complex dance of nuclear fusion is taking place. The star is now fusing progressively heavier elements, a process that will ultimately lead to its dramatic demise. This final act in Antares' life is a precursor to one of the most spectacular events in the universe, a supernova explosion. As the star continues to fuse heavier elements, it's building up to a cosmic crescendo that will outshine entire galaxies. When Antares finally explodes, it's expected to become so bright that it could rival the combined luminosity of every other star in the Milky Way galaxy. Imagine looking up at the night sky and seeing a single point of light as bright as our entire galaxy. This is the potential future that awaits us when Antares goes supernova. The explosion will be visible even in broad daylight, turning night into day for a brief period. It's an event that would be remembered for generations, much like the supernovae recorded by ancient astronomers centuries ago. The impending explosion of Antares offers a unique opportunity for scientific study. By observing this nearby supernova, astronomers hope to gain unprecedented insights into the death throes of massive stars. The data collected from this event could revolutionize our understanding of stellar evolution and the processes that create the heavy elements essential for life in the universe. Interestingly, the name Antares itself holds a clue to the star's appearance and historical significance. Derived from ancient Greek, the name means anti-Ares, or rival of Mars. This moniker was given because the star's reddish hue bears a striking resemblance to the red planet. Ancient astronomers noted this similarity, leading to Antares being sometimes referred to as the heart of the Scorpion in its host constellation. The connection between Antares and Mars goes beyond mere appearance. It speaks to the human tendency to find patterns and relationships in the night sky, a practice that has been central to navigation, timekeeping, and mythology for thousands of years. This celestial rivalry between Antares and Mars has been recognized by various ancient civilizations, each incorporating the star into their own cosmic narratives. The anatomy of a supernova. As we venture deeper into the mysteries of stellar evolution, we encounter one of the most awe-inspiring phenomena in the universe, the supernova. This cosmic spectacle represents the grand finale of a massive star's life, a celestial fireworks display that outshines entire galaxies. But what exactly is a supernova, and why does it captivate astronomers and casual stargazers alike? A supernova is, in essence, the largest observable explosion from Earth. It occurs when a star, having exhausted its nuclear fuel, can no longer support its own weight. The resulting collapse triggers a catastrophic explosion that releases an enormous amount of energy and light. This cosmic cataclysm is so bright that it can be seen across vast distances, sometimes even visible to the naked eye during daylight hours. The sheer scale of a supernova explosion is difficult to comprehend. During this cosmic event, material is expelled at incredible speeds, reaching a significant fraction of the speed of light. To put this into perspective, imagine a mass several times that of our Sun being ejected into space at velocities approaching 30 million miles per hour. This violent expulsion of stellar material creates shock waves that ripple through the surrounding interstellar medium, shaping the cosmic landscape for light years around. But the supernova's influence extends far beyond its immediate vicinity. These stellar explosions play a crucial role in the cosmic ecosystem, acting as factories for the intense heat and pressure during a supernova create conditions that forge elements heavier than iron, which are then scattered throughout space. This process enriches the interstellar medium with the building blocks necessary for the formation of new stars, planets, and even life itself. The aftermath of a supernova is equally fascinating. Depending on the initial mass of the star, the explosion can result in one of two exotic outcomes: a neutron star or a black hole. Neutron stars are incredibly dense objects where the mass of a sun is compressed into a sphere roughly the size of a city. Their gravity is so intense that a teaspoon of neutron star material would weigh billions of tons on Earth. Black holes, on the other hand, represent an even more extreme outcome. These cosmic enigmas are regions of space where gravity is so strong that nothing, not even light, can escape. They continue to be a source of fascination for scientists and the public alike, challenging our understanding of the fundamental laws of physics. The frequency of supernovae in our galaxy adds another layer of intrigue to these cosmic events. It's estimated that between 2 to 12 stars go supernova in the Milky Way each century. Yet despite this relatively high occurrence rate, no supernova has been observed in our galaxy for several centuries. This statistical anomaly suggests that we are overdue for such an event, heightening the anticipation among astronomers for the next galactic supernova. The last recorded supernova in our galaxy was observed by Johannes Kepler in 1604, more than 4 centuries ago. Known as Kepler's supernova, it was visible to the naked eye for over a year, rivaling the brightness of the planet Mars. The long gap since this last observed event underscores the rarity of visible supernova in our cosmic neighborhood and highlights the potential significance of Antares' eventual explosion. A celestial companion, Antares B. While Antares steals the spotlight in our cosmic narrative, it's not a solitary player in this stellar drama. Hidden in plain sight is Antares B, a lesser-known companion star that adds another layer of intrigue to this celestial system. Described as a little spark of glittering emerald, Antares B is a bluish-white star that orbits its giant red counterpart. The relationship between Antares and Antares B forms what astronomers call a binary star system. These cosmic partnerships are more common than one might think, with many stars in our galaxy existing in pairs or even larger groups. The dance between these stellar companions can have profound effects on their evolution and ultimate fate. In binary systems like Antares, the gravitational interaction between the stars can significantly influence their life cycles. This cosmic tango can alter the rate at which stars age, affect their mass loss, and even determine the nature of their eventual demise. The presence of Antares B adds an extra variable to the equation when considering the future supernova of Antares. The study of binary star systems provides astronomers with valuable insights into stellar evolution. By observing how these paired stars interact over time, scientists can refine their models of stellar life cycles and better predict the outcomes of various stellar scenarios. This knowledge is crucial for understanding not only individual stars, but also the broader cosmic processes that shape our universe. One particularly intriguing example of a binary system on the brink of a stellar explosion is T Coronae Borealis. This system consists of a red giant star and a white dwarf locked in a cosmic embrace that's about to reach a dramatic climax. Astronomers predict that T Coronae Borealis will experience a nova explosion between now and September 2024, offering a rare opportunity to witness a stellar outburst in real time. A nova, while less powerful than a supernova, is still a spectacular cosmic event. In the case of T Coronae Borealis, the anticipated nova is expected to be visible to the naked eye, potentially rivaling the brightness of Polaris, the North Star. This means that for a brief period, observers on Earth will be able to see what appears to be a new star blazing in the night sky. The last recorded eruption of T Coronae Borealis occurred in 1946, making the upcoming event a significant astronomical occurrence. Observers can expect to see this temporary new star with the naked eye for at least a couple of days, and it will remain visible through binoculars for about a week. This provides a unique window for both professional astronomers and amateur stargazers to study and appreciate the dynamic nature of our universe. The rapid nature of nova events adds to their allure. As one researcher notes, this new star will reach its peak brightness within 24 hours of the nova explosion. This sudden burst of light serves as a stark reminder of the ever-changing nature of our cosmos, where stellar dramas unfold on timescales both impossibly long and surprisingly short. While the T Coronae Borealis nova and the potential Antares supernova are different in scale, they both highlight the dynamic and sometimes explosive nature of binary star systems. These cosmic partnerships can lead to some of the most energetic events in the universe, shaping the very fabric of space around them. The cosmic ecosystem, life after supernova. In the wake of a supernova, the universe enters a phase of cosmic renewal. These stellar explosions are not merely destructive events, but rather catalysts for creation on a grand scale. Supernovae play a pivotal role in the cosmic ecosystem, acting as celestial factories that forge and distribute heavy elements throughout the universe. The process begins in the final moments of a massive star's life. As the star exhausts its nuclear fuel, it undergoes a catastrophic collapse followed by an explosive rebirth. This violent event creates conditions of extreme heat and pressure, enabling the formation of elements heavier than iron. These elements, such as gold, silver, and uranium, cannot be produced through the normal fusion processes that occur during a star's lifetime. In the midst of this cosmic crucible, these newly formed heavy elements are violently expelled into space. The explosion disperses material several times the mass of the Sun at incredible speeds, enriching the surrounding interstellar medium. This enriched material becomes the raw material for future generations of stars and planets. The elements produced in supernovae are essential for the formation of planets and life as we know it. Carbon, oxygen, and nitrogen, the building blocks of organic compounds, are among the elements scattered by these cosmic explosions. Iron, crucial for the formation of rocky planets like Earth, is also a product of supernovae. In a very real sense, we are all made of stardust forged in the fires of ancient stellar explosions. This cosmic distribution of elements illustrates the interconnectedness of stellar and planetary evolution. The death of one star paves the way for the birth of new celestial bodies, creating a continuous cycle of cosmic renewal. It's a testament to the dynamic nature of our universe, where destruction and creation are intricately linked. Despite the crucial role supernovae play in cosmic evolution, predicting which stars will go supernova remains a significant challenge for scientists. The difficulty lies in determining the precise stages of fusion occurring within a star's core. Many stars, including red supergiants like Antares, may have millions of years left before they reach their explosive finale. The complexity of stellar evolution makes it challenging to pinpoint exactly when a star will exhaust its nuclear fuel. Factors such as mass, composition, and even interactions with companion stars can influence a star's lifespan and eventual fate. This uncertainty adds an element of cosmic suspense to the study of massive stars, as astronomers watch and wait for signs of impending stellar demise. However, the study of red supergiants like Antares provides valuable insights into the conditions that lead to supernova events. These massive stars are in a critical phase of stellar evolution, having exhausted their primary hydrogen fuel and now fusing heavier elements. By observing the behavior and characteristics of stars like Antares, astrophysicists can refine their models of stellar evolution and improve their ability to predict future supernovae. The data gathered from studying red supergiants helps scientists understand the internal processes that occur in the final stages of a massive star's life. This knowledge is crucial for developing more accurate models of stellar evolution and supernova mechanisms. As one astrophysicist noted, supernovae are indeed fascinating phenomena like no other, and they serve as a reminder of the dynamic processes that govern the universe. Each observation of a red supergiant like Antares adds to our understanding of these cosmic giants. The variations in brightness, temperature, and spectral characteristics provide clues about the internal furnaces of these stars. This information, combined with theoretical models, allows scientists to piece together the puzzle of stellar evolution and supernova prediction. The study of supernova and their progenitor stars has far-reaching implications beyond astronomy. It touches on fundamental questions about the origin of elements, the formation of planets, and the conditions necessary for life to emerge in the universe. By understanding these cosmic processes, we gain insight into our own origins in place in the vast cosmic tapestry. Witnessing cosmic history. The universe unfolds its secrets to us in rare and spectacular events, and few are as awe-inspiring as a supernova in our own galaxy. These cosmic explosions, marking the dramatic end of a star's life, are not just visually stunning, but also scientifically invaluable. Yet despite their significance, observing a supernova in the Milky Way is an exceptionally rare occurrence. Consider this. The last recorded supernova in our galaxy was observed over 4 centuries ago. In 1604, Johannes Kepler documented a stellar explosion that was visible to the naked eye for more than a year. This event, known as Kepler's supernova, rivaled the brightness of Mars at its peak. Since then, our galaxy has been notably quiet, at least from our Earth vantage point. The scarcity of observable supernovae in our cosmic neighborhood makes the potential explosion of Antares all the more significant. If this red supergiant were to go supernova in our lifetime, it would offer an unprecedented opportunity for scientific study and public engagement with astronomy. However, the apparent lack of supernovae in our galaxy doesn't mean these cosmic events are not occurring. Modern technology has revolutionized our ability to detect and study supernovae, even if they're not visible to the naked eye. Advanced telescopes and sophisticated detection methods allow astronomers to observe supernovae in distant galaxies, expanding our understanding of these cosmic phenomena. These technological advancements have opened new avenues for research. Astronomers can now study supernovae across vast cosmic distances, comparing data from multiple events to refine our models of stellar evolution and explosion mechanisms. This wealth of information helps scientists piece together the complex puzzle of how stars live and die. The potential future observation of an Antares supernova would be a game changer in this field. Being relatively close to Earth at about 604 light-years away, Antares offers a unique opportunity for detailed study. Its explosion would provide unprecedented data on the death throes of a massive star, allowing scientists to test and refine their theories in real time. Imagine the wealth of information that could be gathered from such an event. Astronomers would be able to track the supernova's evolution from its earliest stages, observing changes in brightness, temperature, and composition as the explosion unfolds. This data would be invaluable for understanding the physical processes that drive stellar explosions and the formation of neutron stars or black holes. Moreover, the explosion of Antares would offer insights into the production and distribution of heavy elements in the universe. Supernovae are cosmic forges, creating elements heavier than iron and scattering them across space. By studying Antares' supernova, scientists could gain a better understanding of how these elements are formed and dispersed, shedding light on the chemical evolution of our galaxy. The public impact of such an event would be equally significant. A supernova visible to the naked eye would capture global attention, potentially inspiring a new generation of astronomers and space enthusiasts. It would provide a rare opportunity for people worldwide to witness cosmic history firsthand, fostering a deeper appreciation for the dynamic nature of our universe. However, it's important to note that predicting when Antares will go supernova remains challenging. While the star is in the later stages of its life, it could still have thousands or even millions of years left before it explodes. This uncertainty underscores the need for continued observation and study of Antares and other potential supernova candidates. In the meantime, astronomers continue to refine their methods for detecting and studying supernovae across the cosmos. Each observation, whether of a distant galaxy or a nearby star, adds to our understanding of these cosmic events and their role in shaping the universe. A new chapter in cosmic understanding. The study of Antares and supernovae opens a new chapter in our cosmic understanding. These stellar explosions not only distribute heavy elements crucial for planet formation, but also provide insights into the life cycles of massive stars. As astrophysicists refine their models, each observation of red supergiants like Antares brings us closer to predicting future supernovae. This ongoing research enhances our comprehension of the universe's dynamics and our place within it. The potential explosion of Antares represents a pivotal moment in astronomy. It offers a rare opportunity to witness cosmic history and advance our knowledge of stellar evolution. As we continue to explore the night sky, we're reminded of our deep connection to the stars. The cosmic drama unfolding above us is not just a distant spectacle, but a fundamental part of our own story. In the words of one astronomer, supernovae serve as a reminder of the dynamic processes that govern the universe.